Hello, hello. All right, let's continue here. Oh, this one is done. Phase 1 strings complete the current 5 elements. Condition 1 helpful 3 ways. Stage references single parameter. Void sending functionalities, the upstream valued parameters, so this function was good code, user, and the pipeline stage. Okay, so wait, this shouldn't work. Why didn't it ask me if I wanted that? That changes things a lot. But oh, yeah. This is actually pretty cool. A string has a UFCS method, as they call it here. Essentially, you can have a string dot shout. You know, it's a member function, and then we can like pipe a string into the same function essentially. But now, like, the input is kind of like the pipeline input. So that's pretty cool. I didn't want this though. This is what I didn't want. I guess it's pretty simple to remove because we can just remove that way of doing things. But okay, type checker returns parameter type. So by the way, this is runic here. I'm just running like the AI at the same time to kind of. I just need to answer this so it can keep working here. Type checker result pipeline says and it returns parameter type not void for one param. Boundary matches. Try compile pipeline param stage disfigures the stage to correct boundary blah 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 blah. Exactly one parameter receiver stages only and standing stages are unchanged. Param stage chain and mixed with standard stages. The one node limitation collects the input as a string, so a type scale parameter int would need typed transport noted as a follow-up. Oh, so it doesn't work for all types. It just works for strings. String helpers work fully. Okay. Well, it should work for everything, not just strings. Alright, so we have string built-ins now. A bunch of nice things. I might look into what's needed as well. Pipeline, parameter, coercion, unifying call method pipe. Right. Okay. Why did you add this way to call methods? That is strictly against the language philosophy. All function calls should be in the form for a member access function You're right, I want to be clear. Did not add a C-style call feature, was sloppy prose in my summary written out of habit, and it contradicts the language philosophy. There's no parenthesized call in syntax and anything. I built the call forms were made. Okay. What the hell? So it just hallucinated this. Okay, well, fine. Let me verify the styles of committed text. Okay. God damn it, Claude. Not again. All right, so I just need to send it to the next thing here. Okay, you didn't add it. It was a mistake. Blah blah blah. Yes, blah 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 blah. Parentheses. Right. So I mean, I guess technically you could still write this. I guess because you can have parentheses around an expression, and that expression will be the argument. So I guess this could still be valid syntax, except it's a little bit misleading because if you add commas and try to add more arguments, that won't actually work. That will be a parse error. Excuse me. Order is clean, blah 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 blah. Verified constants advance. Fix the pros. Okay, just added a space in essentially. Okay, good. Yeah. Thanks. Okay, so let's continue with whatever we had. Phase 2, I guess. Actually, what about typed pipes? Typed pipe coercion as well. Okay, let's do the follow-up on function to pipeline stage coercion with typed piped support. Let's just see what the hell is doing here. All right, so we have a void double, so it takes an int, returns an int, and then we kind of, so the idea here is that if you have a function in this form where you take one parameter and you produce some type, and then you can use it in a pipeline stage, even though standard in is void, it coerces this to standard in. So it can still take the integer and output an integer. Okay. Yes. I'm surprised that wouldn't like just automatically work because it's just a. It's basically just. Maybe you could just make a new function that has that signature. Gives 42. It already flows through. Okay. Good job. Hello, Penguin. All right. Okay, so back to this game. Now, I've got, you know, the movement. So last time we did an animation, monadic animation combinator kind of library, you could say, and which means that we can basically make any kind of arbitrary like animation that's gonna affect stuff. I mean, it potentially, it doesn't really need to be an animation. It can be used for anything, really. It's essentially a scheduler. So really, you know, but it's meant to be used for animation, but it can be used to basically do anything, really. It's like a scheduling monad, where you can run tasks in sequence and in parallel, and it waits for, the whole thing is like, yeah, it's waiting for something to finish. When it's finished, you receive a payload, and there you go on to the next thing in the sequence and so on. Yeah, so a really powerful kind of very generic way of doing things. And I have made, so the simple move animation that you see here is made with that system. There's also the attack. As you can see here, the attack animation is just moving half a tile forward and half a tile back. And yeah, I did not fix the ranged animation though. So that's going to be next on the agenda. So let's do that. Here is the move animation. I also had to kind of break this out into two paths, because if it's a player, then we also want to emit, once the animation is done, we want to emit a move done event, because then it's like, well, I mean, we don't have to. I guess we could do it in two different ways. We could check if we're supposed to change location. This is just so that we know that we need to change location, because if you move onto the village, we want to know if we've moved to the village and we need to change the location. But we can do it in another. So the way that I do it now is like, when the animation is done, we get a move done event, and then we have a handler that takes that event and basically changes the map. And so, but we could do it in another way. Is like between, like when all the animations are done, we do like an end of turn or something, an end of turn handler. And that end of turn handler will check, okay, is the player on a location? Then we have to change the location. Or did the player move on to a location, I guess, would be, I guess, more accurate maybe. Because let's say we're out here, now we're on the location, but we didn't move there. So if we stand still here, we'll still move into the location. We can also do it so that it's like you don't, it's not like you move into the location. This is more like Final Fantasy style, where you move into the location to change it. Whereas maybe like more like classic roguelike is you can actually pass through a location without going into it. And the way you would go into a location is like mapped to some key, to some action button. Like, so that would be like, so you have to decide, do you want to enter the location? So that would be mapped to a button. That would be even more easy change. Actually, that might be even better, because then that is mapped to an actual action instead of a thing. So that will be, yeah, something that might take time. Maybe when, like, let's say you're in a dungeon and you want to move to the next floor, then the action of like trying to go down the stairs is gonna take time. So maybe a monster will like have time to kind of catch up and hit you or something. I think also like in some games, if you have a monster right next to you and you move down the stairs, it's gonna follow you down, so you can't really escape by just going down the stairs. But anyway, I might do that. I might do that change, but it's not super important right now. Oh my god. Oh, I see. I see what happened here. Hey, yo, Lucas Develops. Welcome, welcome. Thank you for the raid. Did you just finish the stream? How did it go? We just encountered a bug here. If I go into the enemy location, I go out. Okay, there's another bug as well. It doesn't clean up properly. Actually, you know what? I think the bug is like this. You go around, you do a bunch of turns. Oh man, I never actually considered this, but you do it a bunch of turns. Small raid. Yeah. It's not the size that matters. And then we go in here, and now the monsters get like, they get to catch up to all the turns that I did. That's not great. And he got like 5 hits on me. Also, they follow you out to the thing. All right, thanks, Lucas. Have a nice meal. Okay, but those are like, that's not what's important right now. All right, so let's continue with, I want to also move the range attack. So okay, so what I will do, might move this to an end of turn check instead. All right. So let's do the ranged attack now. Also, this is kind of nice because this change is kind of making these actions very simple, because we don't need to worry about any animation stuff in here. Most of this stuff is just for animation. And then the important thing is like, what direction do you want to move in? That's essentially all that's needed for this action. And essentially, we don't need a component for this. We don't even add the attack or the action component anymore to entities. We just essentially call the onCreate function, which will do the board kind of state update, and then it will also cue an animation to be played, which is the move animation, and then we're done. So that's essentially how the kind of gameplay is like now. Is like the turn system will determine whose turn is it. Those entities will decide their move in sequence once, and then they will also cue their animations by this function here, and it also it changes the board state. It cues the animation when all those entities have done their turn. Then we play all the animations in parallel, and then we can also decide, okay, do we have animations that have like we can have special kind of animation, for example, like a fireball that has like super high impact, which means that it's gonna show its animation in sequence instead of in parallel. But anyway, they've done their turn, they've decided what they're gonna do, the board state is updated, they cue their animations. When everyone has done that, the animations are played out. When all the animations are played out, the board that now it's back to the turn system to determine who's next in the queue to do their turn, and so on. And then it repeats. So it's like turn base. Whose turn is it? Make your move. Cue your animation. Play all the animations. Next entity's turn. Right? So technically, this move action thing, I can actually like try to change it so that it's not actually like a component anymore. But anyway, let's do. And in fact, I never actually add the action component anymore. I'm just using the onCreate function essentially. So an action now is essentially just a function with kind of like a payload, or a function with like a closure with the direction function here. So, and we've done move, have we done idle? I think idle doesn't even cue an animation, and it doesn't really do anything it doesn't do anything at all, actually. So it's like, we don't need to do anything with idle. So we've done move, we've done attack, melee attack. What this also means is that, for example, the melee attack system, we can just remove now, because the only thing this did was update the animation. And since we're using the generic animation library now, we can just remove the entire melee attack system as well. So I'm gonna do that. Let's remove that. And also the move system. We can remove the whole move system as well. And so remove that, remove move. Let's remove the ranged attack system as well. Yeah, let's just remove it. And we'll remake this from the monad instead, which is way easier. Okay. And now we go to setup systems. We'll remove these. We go to update. We can remove all this. And the idle system doesn't actually do anything. Well, I guess all it's doing is like it's saying that it's done. You know what? We don't need this either. Actually, because we can make it the same way we do the other ones. We can have an onCreate. Let's do this one first, because this one is super simple. This creates a... Well, this does things. What was the thing here? onCreate, let's copy you. You also get the context. All right. So we don't need any position. We need the animation system. We don't need anything there. We just need to play an animation. What is the animation that we play? Pure void. This essentially, it's not even an animation. It's just the pure is basically just saying, you know, it's empty essentially. So yeah, cool. And then we don't need the idle system. Where's idle? Here. Cool. So all that is now done through the animation sequence system. Nice. And as I said, like technically, this thing, we can kind of use this for any kind of scheduling thing that we want. Right now, how it's set up is like these animations are played between turns. But if we would for example, need other types of animations, tweenings and stuff like that, we can use the same system for that as well. We just need to set up like some kind of thing that runs in parallel or something that is managed in another way. But we can potentially use it for or, you know, any kind of timing, I guess, based thing, time-based thing, essentially. Okay. So if we go to range attack component now, look at all this crap here. Basically, I do it like this. I say, remove all this crap. The only thing we need, I think, is the... Well, we'll see what we need, actually. We don't need you. We need basically the input here. That's what we need, I think. So that gives us the position, and we calculate the number of steps. And I think, you know what? Yeah, and these steps are actually just, we don't even need this anymore. Like, I don't think we need this. We don't need this, because that's going to be counted. This is all for the animation. Let's just do this for now. We do need, you know, we need some information, but that's gonna show up whenever we are doing our actual animation. We don't need this because that's only used by the and like the range attack system doesn't exist anymore. Only for animation. So now we need to get the animation system. We need to play an animation, like cue an animation. That's basically what that means. And we need to actually create this animation. So this would be the ranged attack animation. And what do we need for that? I think we even have... Actually, I think we need to implement another primitive for this one. But this one was one of the examples that I was working on here. It's this one here, ranged attack. Let's just delete this from here. And this would be an animation monad, void, and right. So basically what we want is we want to create a new sprite that is the projectile sprite. We bind it to move and destroy. So it's going to get, it's like tweened or moved to a target position, and then it gets destroyed. And then once that is done, we show the damage number. We don't have a damage number primitive yet, so I'm gonna remove that. And we don't have a sprite primitive, so we need that. Also, we need the attacker position. We also kind of need the target position here somehow. Yeah, so maybe the bind, we need like a closure. That could be a thing. Yeah, so we could need, I think we need a closure. Also, this needs to be like this. All right, because otherwise we don't have target position. That's the thing. We do have sprite, but we don't have target and we don't have speed. So what I'm thinking is that for bind, anything that has like needs a closure, what we could do is we could say that this would be the cont anim struct. We have a function that is called, I don't know, animation, perhaps. It has to be something that is like adhering to some kind of you know, pattern. So animation, it's important that its name is animation. And then we have the closure. Well, it can be anything actually, because yeah, so we can have target position is a vector. We can have speed, and simply here it's just going to be self this, target position and speed, and there we go. And then if we pass in a type, maybe we can have a check, like you pass in a, if you just pass in a function, maybe it would just you know, not bother with the closure at all. If you pass in a type, it will, or if you pass in a struct, I mean, actually, because we need, yeah, we need to actually have this as a struct here. Yeah. And this could be called like move projectile, like, or something like that. So you can, it's a little bit move projectile animation. Okay. So if we go to bind, now fam is anytype, so it doesn't have to be a function. So we have to get the function somehow. If the function is, if type of, so I'm gonna say fam equals, if type of fam is, if the type info is a function, if it's a function, then it's just going to be type of fam. Otherwise, it's going to be like fam dot, like type of fam dot animation. So that's where it's important now that if we pass in a struct instance, we are going to grab out the animation method on that, and it's going to tell us a few things. Actually, it's going to tell us the animation has to be there. It's going to tell us that if it's a function, it has to be well, we can make sure it's a function. So if like type info fam is not equal to a function, then we get a compiler saying input needs to be a function or a struct instance with an animation function. Right. Okay. So that's kind of we're kind of building like a little constraint here of what you could put in. All right. And then fam would be not actually the function itself. It's going to be like, I guess, bind argument. Let's say. And we need actually a type function that gets the kind of return type here of the bind arguments, either the return type or the bind arg function of bind arg gives you a type. It's gonna give us essentially this. That gives us the actual function out. So if bind arg itself is a function, we just return that. Return bind of. Otherwise, return this. We can also probably have and now this would actually be bind arg function, bind arg, right? And now this is return type of the function. Okay. And so the return type is going to be mu. Yeah, that's what we're doing here. So this is the bind arg function. And I wonder if I can use mu here. No. That's unfortunate. It's like there's no way to kind of alias things that has the scope of being available here and down here. I wish there was. Because now we have to kind of repeat that. Yeah, and then we have mu, and we have the payload. Okay, so what else? Bind state of this. Bind arg bind state takes. Let's move you up here actually. Oh, that's right. So bind state of fam. Now, yeah, we need to store the whole bind arg actually. So this would be the bind arg. And mu is the bind arg function of bind arg. Wait, this is wrong. It's not an animation monad wrapped in that. It's the actual. No. Okay, yeah. Wait, we take the payload and we wrap animation monad. Yeah, that's true. That's correct. Okay. And then fam is just going to be. Actually, this is not fam anymore. This is bind arg. And that's just type of bind arg. Okay. And then over here we get the state. And instead of having, well, if we have the mu already, there's no difference here. But here is, instead of saying bind arg t, we need to know if bind arg is a function or not. So if, actually, shouldn't we just be able to get the function out? Well, I guess we'll do it here. So if type info type of bind arg is a function, then we can do this. Then it's just the same as before. Otherwise, we have the animation function. So then we have to call dot animation. And I think that's it, because then this is a member function, so it will have the state we need. We just call dot animation instead of calling the function immediately. All right, you need to be dot function, that's right. Okay. Cool. And now we need attacker position. So we need like, well, let's just get, I guess we'll just pass that in. We need target position. And we need speed. Source rectangle. Oh yeah. We need the projectile source rectangle as well. Yeah. Move projectile animation. Excuse me. You know what? Okay, there we go, I guess. So we bind the sprite to move projectile animation. Once that is done, we destroy the thing. Yes. Yeah, that's essentially it. I mean, this, you can kind of read this as the whole range attack animation is essentially just a projectile being spawned, and then we move it to the target position. And it's gonna get destroyed as well. Yeah. Cool. All right. So that is then gonna get played. We need to supply a bunch of things. Attacker position, target position, speed, source rank. Speed is, I'm gonna say it's just 1, I guess, for now. We need the target position. Attacker position. It's just gonna be get body position. Target position is self. And now we actually need the target here. So target. Target get body position. We need the projectile source rectangle. That is going to be some kind of vector. Actually, it's probably easier to do this. And then it's like tile size. And then the size is just the tile size. The projectile. Oh yeah, we didn't actually do this before. I wonder if there is a projectile. These are all characters, fonts. Do we have like project? I mean, I'm sure we have somewhere. What is this? sure what that is. This is all space stuff, car stuff. Weird stuff. No, this is like, yeah, this is RPG. This is fantasy stuff here. Now, where are the things? We have weapons here. There has to be an arrow in here somewhere. Otherwise, we could just make it. Well, that's, I think that's more like a spear. Different kinds of spears. Oh, hey, oh my god, it's just right here. Okay, so, I mean, I guess, oh, a broken one as well, nice. I guess this one. This looks a lot like an arrow. So, let's grab that. Is there, because this might be just to show on, like it's on the ground or something that you can pick up. Maybe there's another version where it's like meant to be used to actually show a projectile, maybe, I don't know. Let's just have a little look here. Here's like a bunch of tools. Cool. A harp, guitar. You have to really like pay attention, because then otherwise you miss. It's like you go back every time you go back to this tile set, you discover something new. Okay, so I don't see anything. Okay, let's just use this one, I guess, and I will kind of rotate it, I think, depending on where it's aiming or the velocity. 430, 131. 430, 131. All right. Okay. So also what's missing here is also we don't have the sprite. Kind of thing. So what we'll do is we'll go to the animation thing, and we have to make a sprite kind of thing, a sprite primitive. I guess we can copy move for now. All right, so this would be sprite. We need position. Where is it gonna get created? We need the actual source rectangle. I think that's it. Position and rectangle, right? And that's gonna create us the actual sprite. And we can then determine what we need to do with it. I don't know if we need to have like an actual like implementation function here, or if we can make it through other moded constructs. So essentially, you could potentially just, I guess, you know, we can have a lift function. lift will take a function, give us the monad. This will be the return type of f. F u. Let's just call it u. Animation monad, interesting idea. Hey yo, Julian, what's up? Welcome. Yeah. I mean, the thing is, like, I wish Zig had. Well, I'm trying my best here, but I wish Zig had a little bit more. Like, if Zig had a tiny bit more, like, I guess, syntax friendliness regarding like some of the functional stuff, then this could actually be very feasible, or even more feasible, I would say. But it does work. It does work. The question is how, if you have like these simple examples work really well, but as soon as you want to have things like bind and stuff like that, it can, I guess, get a little bit messy, and you kind of lose a little bit of the niceness and elegantness of the monad. But yeah, we'll see. So u is going to be the return type of f. All right. And this whole thing is a u. We get a u out. And we'll get the lift state. Now the lift state actually is gonna be, this is also a trick that I've learned here. You can define the lift state in here, and then you have, you can define the type in here. You have access to all the type information that we need. We don't need anything of this sort. We just need the actual function that is going to be type of f. And actually, it's we can kind of say better what it is actually, but it's like a function that returns u essentially. It could also take like the context, so we can, yeah, it has to have like game, so we can actually create something. But then we can actually, we could do create. As a monad construct instead, if we make create. Okay, let's think about this later, because if we introduce, if we have, I don't know, man, lift. The thing about what is the input then? It's just going to be a void. It's just a function that gets called. We get something out. I mean, in Haskell, this would just be if a function that doesn't take an argument is not actually a function. It's just a value. So what the hell does lift do? I think lift takes a function. It turns all, maybe it turns like all the arguments into monad. Hang on. Let's bring up the functional helper thing here. Google. Search for lift. Yeah. So essentially, you take a function that from A to R, you lift it, you will now get a function that takes m of A and returns m of R. So it's like I mean, I guess it no, wait. Okay, what do we actually need here? We need to basically create an entity when the animation starts. I guess lift is wrong, maybe. We need like something that triggers and gives a payload when the animation starts. It's kind of like a primitive of the monad, I guess, maybe. So maybe it's not lift that we need. We need like on start. Which takes a function that produces a value that we will then have as a payload for the next thing. On start though, it just sounds like a event listener. And usually those just don't have a payload. So I'm not sure if that's a good name, but anyway. So essentially we just need F. However, we do need more things though. We need like the context as well. Animation monad context to be able to get game. Maybe we just get game actually. Yeah. So this would be a function that takes game and returns U. It could also be a closure, actually. What if we just make it a closure? With the same way we do bind, we make it a closure. Because then you could just get put game in the closure, actually. Let's do it like this first, and we'll see what we can do. We don't need to make it like... We don't need to philosophize here. So we need this. We need, this is going to be the on start state, where F is F, and I guess potentially we could just get game from here. No, we can't because we don't have it. Okay. And then when the animation starts, we call F, and so basically the only thing we really want to do here is essentially we just return state F context game. That's all we do. And then the animation is done. This step is done. It just calls the function, returns the payload. It can be a side effect, because that's how it works. All right. So we have on start. Now we can, I think, move on to sprite. And I think sprite can just be oh, we need a closure. Because we need these things. Yeah. Okay. So we do need a closure. Maybe I can try to make like a more generic way to deal with closures. Because the bind already kind of has this now. Where is bind? Here's bind. So we have like this thing. You know what? We could just move this into. No, because it's a. Wait, yes. Yeah, we could just move this into here actually. We don't actually need this to be a function because we can just have it here. I just realized. And then we actually have, you know, access to all these things anyway. Yeah. So the bind state, we don't need to have a function there. Okay. Now, the closure stuff. So I guess we'll just copy this for now. I don't know if we can get a good pattern right now for this. I'm going to say that also the thing about closure is like, what is the function name gonna be called? So it's like, I guess closure function. How do we get out the closure function? Do we even need this function, this thing? I guess we do, because we need to know the return type. Yeah. So to get the closure function of this argument, we get a type. If the thing itself is a function, I guess it like it can work with both closure function of. I guess it could work with both function, like it's a function itself, then we just return the function itself. Otherwise we will return dot. Actually, let's do like function name, and here we can say field of arg call with function name. There we go. Okay. So this would be like a closure. Potentially, it can be a closure or f, you know, or a function. So the state is f, but this is actually, I'm just gonna say it's type of f, and actually this is arg. And instead of return type, it's gonna be closure function of arg. And we can also make on start function of arg. This is a function, returns the type. We just return closure return closure function of arg with an actual like name on start, I guess. So this would be, so don't have to say that everywhere. Okay, so then u, so actually f is on start function of arg, and then u is return type of f. Do you work with both types? And no, you don't. If type of f is a type, then return type info f function return type or else void. Okay, now you work with both types and actual functions. Where did we go? Here we go. All right, so we have function type, we have you. The state is just the function itself or the closure. I'm gonna call you arg. Call, I guess maybe we can have a function that's like call closure or something like that. Maybe we can have additional arguments as well. This is the f or closure, I guess, and then we can have arguments potentially. And then this would be the return type of, this would be closure function of arg. The name is, we have to actually pass that in as well. So fname is a thing. Closure function, and then this would be the return type. All right, so here's essentially just if f is a function, return this with args. Now, I think you can do like call with args, any type. Hang on, what is args? Is it a enum? I guess we'll find out. Hello, Rudy. Zig, yes. Zig. Are you a Zig person? So call modifier, I don't think it's like just to auto. The function is f or closure. The args is args. I think that works. I'm not sure if args needs to be a constant slice or if it needs to be a tuple. I have no idea. But usually when they have args any type, it's a tuple. So anyway, if it's not a function, then we are just gonna assume that it's a struct with fname in the thing, and we do the same thing. We call, actually no, this is wrong. Well, wait, will this actually infer, will this call, I guess we'll find out. The thing is here is like the first argument has to be self, right? It has to be the actual closure here. So when you do this and you call this function, I don't think we'll get that. I'm a wiser person. What was that? What is that? I don't think we get the self argument here, which is a bummer. Now, if this is a slice, we might be able to put the two together somehow. Yeah, I don't think this will work. We're gonna get a compiler, but let's see if that works. All right, so we have like call closure on start of. Let's also do like call on start closure, and this would be return type closure function. No, this is on start function of for closure. We simply call closure with on start f or closure. Wiser is wiserlang wiser. Interesting. Never heard of this. The Wiser programming language. Static type, compile, resource-oriented programming language. What does that mean? With integrated distributed safety via choreographic programming and per-se-use memory model. Okay, a lot of stuff that I have never heard about. Right, and they kind of say this here. What is choreographic programming? I don't know if like bread text will tell me. I want to see examples. I don't know. In traditional distributed programming, you write separate code for the client and server. Hope they're right, so it's networking. Hope their communication protocols match up. Choreographic programming allows you to write a single unified view of the entire distributed system. The compile then mathematically projects the single script in deadlock-free independent binaries for each physical node, client and server. Okay. Is it networking? Because it feels strange. What is the PERSYS memory model? PERSYS is a fast deterministic memory management strategy that avoids the unpredictable pulses of garbage collector and the complex annotation of a borrow checker. It uses precise reference counting to know exactly when a value has a single owner, allowing the compiler to mutate the data directly in place without making copies or pausing the program. Okay, interesting. One ownership rule for everything, no garbage collector, no broad checker, deadlock free by design, avoid hidden magic, C ABI compatibility. That's pretty good. Pretty good. Rules we follow, syntax to be kept concise, avoiding to be abbreviated. Base syntax should be kept minimal, everything extra must be under standard library. Cool. Something shouldn't be made simpler beyond simple. Okay. I'm not sure what that means. Examples. Distributed key value story. Once you write one program describes how multiple systems talk to each other, the compiler automatically infers network sense and verifies ownership across nodes. It's a cool concept. Does it work? I guess it works. I mean, it seems to be a thing. So do you get like so how is it like hosted? Do you get like an executable? And how about the client? Like, how does that work? So I'm guessing the client is for, it's not for the browser, or it's like it's for like a just an executable for the client or something, or how? What is the use case here? Customizer merges choreography with PERSYS linear typing, and network transfer acts as an absolute linear move. Transferring ownership of a variable across the network consumes it locally. Attempting using GAN produces compile time error. Cool. Oh man, this looks like something I don't like here. C++. Okay, cool. Role, client, and server. String at server. String at server. So it's kind of like code splitting in a way. Maybe you can compile it to WASM. Or how... If you can compile it to WASM, maybe you can run it on a browser as well. And then you would use like a browser API. That could work, right? It is code splitting, yeah. The client gets split by compiler. Okay. I mean, we kind of already have this in like Next.js, for example. But again, I mean, yeah, that uses TypeScript, but yeah. And this would be more like an actual programming language. Well, a compiled programming language, I guess. And not an interpreted one. Cool, cool, cool. All right, the more you know. Well, it's not the same kind of, use area as Zig, so I don't think I don't think you're ever gonna stand between, kind of choosing between Zig and that, depending on what you want to do, I guess. I mean, sure, you can write a web server in Zig. Actually, but yeah. I feel like web servers, I mean, I guess it depends on what kind of web server you want to make. If you want to make something that's super optimized. But yeah. I'm working on generalizing choreographic programming. Choreographic programming. Is that just splitting code? Is that what you're talking about? Yeah, because they said like it was the hey Offsetter, what's up? What's up? Have you heard about this language here? Wiser. Are you making it, Rudy? Are you the author of this language? Because that is awesome. You are the author. Nice. Its selling points. It's a code splitting compiled language for backend client stuff. So server client. So you would get like you would get like all the compile. Maybe you can sell it better, Rudy. I don't know that. I mean, do you know about code splitting, Hofsetter? Hofsetter. Linear types. I don't know what that means. X must be used to consume exactly once. Okay. Yes. So this is this. It's that, but it's like it's not TypeScript or Node or Next.js or. it's an actual compiled language. That's pretty cool. Does it compile natively, Rudy? Or what does it compile to? It has C ABI compatibility. Cool. Cool. Awesome. All right. Cool. Well, I hope the project goes well for you. It's actually pretty interesting. Like, basically what I'm wondering is, can you use it now to make something? Or is it still like in heavy development to kind of like, can I clone it down now and use it? You know, to test it out. I mean, you have like a bunch of examples and stuff. I guess these all should work, right? Choreography test. So, okay, choreographic programs provide 0 deadlocks. There's no message mismatch if A sends an integer, B is guaranteed to expect an integer, compiler automatically matches data types across the network, and it also proven protocol adherence, which eliminate human integration errors. Cool. And do you have like what happens if there's like an error? I believe Veil also have linear types. I played around with it quite a bit in the past and found the entire type system really nice, especially around resource management. Veil, another language I haven't heard about. I don't think. Compile LLVM, statically typed, uses new generational references technique for a memory safety and speed and flexibility. Will soon have region borrowed checking to make it even faster. Safest native language thanks to generation references of fearless FFI. All right. Are we talking about local application errors? What if there's like a network error? I don't know. The client, maybe the client loses connection, for example, in the middle of like sending something. How does it work? Like you want to get like a larger struct that is sent, you know, maybe, I don't know. Yeah, so if the client goes offline all of a sudden, can there be like an error showing up there, or is the error like built into the type, or is it like implicit errors or explicit? A runtime error. Okay, so it's not yeah, it's a runtime error, but can it be caught? Like, is it part of the is it part of the type, or is it like is it like an exception or something? Is it like error by value? Wow, a bunch of contributors to C3. What do you think about C3? Modulo. Oh, it's a function. I was like, is this a built-in? No. X fault def division by 0. Oh, that's okay. So this is like an error. So question marks mean it can be an error, I guess. Hello, Rupert. What's up? C3 released? I don't know. It's 0.8. C3 calls and faults need to be explicitly handled. The thing about question marks, especially since this is called the optionals, to me this means optional and not an error. There's like two different things. But I guess maybe here it means the same thing. It's like instead of null you have errors, like you have to have an error type. Optional can return both null and errors. Okay. Yeah, faults need to be explicitly handled. Nice. Just like in Zig. You'd rather write C3 than C, and I don't usually say that. Would you rather write in Zig than C? Because I would. Alright, cool. Reflection. What is this? What is this? PHP? No, I'm just kidding. So you get like type, macros, macros, right? Macros. So more advanced macros. All right. Now the question is, wait, you have prints inside of a macro? Oh, because it's right. It's code generation, right? So for each field, you would do stuff. Okay. So yeah, you can do that in Zig as well. I'm comparing here. Now you haven't seen my docs on my language, Rudy. Even though it's like I've always said it's like a toy language, but yeah, it's not really super serious. Stack type and implementation. So when you have things like this, can you? It's like extension methods in C#. It's like you can define a function like outside of the outside of like where it's defined, so you could potentially add more functions to it. Like you can add your own functions to stack in your user code. Is that how it works? Okay. Isn't that what if you use a library that kind of pollutes the, because JavaScript had an issue with this, like but of course JavaScript was, you get a runtime error instead of a compiler, but you would get like a pollution. They call it like pollution of the, I don't know what they call it, like the namespace or whatever, where a library or something would modify, basically, for example, strings. It could like add functions into strings, and then what if like multiple libraries did the same thing? Then you would get a conflict all of a sudden. I guess, you know, here you get I guess like a type error. Or a or like duplication. Okay. Plus plus. Plus plus. Yeah, that's the thing. That's the thing. Distinct types and aliases. Okay. So alias is like exactly the same thing. Type def is kind of like treated differently, I guess. Then it has to be converted. Okay, but it is an int still. So that reminds me of Haskell. Like Haskell has like the same thing. Essentially, you can have an alias or you can have like a new type. New type. I think it's called new type actually. And then you can have like different implementations based on what type you put in, even though the kind of underlying type is the same. And in Zig, you would probably use something like a union enum or something instead, or just a wrapper struct, I guess. Wait, equal x, but you can't. You have to convert if it's okay. That's it. Cool. All right. Cool. Okay, another one. Nova. Simply minimal programming language for the future. The world will hype don't focus on times for resisted near a portable micro IR designed for efficient, flexible code generation on RISC, CISC, CPU, ISIS. Does it only work for those then, or new minimal high-level language embraces modern programming principles to neural networks and well-stepped linear? Regarding conflict, nothing stops conflict from happening, but it's visibility scope to the module itself. So that's a big difference. Oh, so it's not going to be like added to the type globally. So if you have a library that adds more functions, you are not like as a user of the library, you won't get those functions. But how do you? Or how does that work though? Or do you decide about the visibility at the declaration of the function, or because otherwise you wouldn't be able to export. You decided to import modules. Okay. Because I was about to say, otherwise you can't like define any functions anywhere because it will be only visible within this module. So if module A and B both declare an extension foo on int, we have a problem. Right. I mean, I think it's good that you can extend, I think. But I think libraries shouldn't extend, you know, standard library types. Only if you import both A and B. Okay. And I'm vibe coding. I'm vibe coding Runic here. Have you seen my language? Okay, while we're here, let me show you my language. Where's my language actually? Well, it's kind of out of date. You have to go in like, well, don't look at the docs. Look at the examples here, or the tests. Actually, the test is probably better. Features. So this is kind of like Bash. It's just for me to be able to avoid using Bash. Okay. I think vibe coding is okay if you do it correctly. If it's your own project, even if it's open source, I don't care. It's like people can contribute if they want. Like this is open source, and I'm vibe coding it. I don't care. What's the harm here? It's just my personal project that happens to be open source. People can use it if they want. They can contribute if they want. I don't see an issue. I do see an issue if you have like an established project that is like more important, if it has more impact, and then all of a sudden you get like bad quality code, then that's a problem. Because then it's like actually used by other people and everyone gets mad and sad. What model use? I use like Claude something. I don't know. I use some like the default. Oh, thank you for the follow. I can't read. Le Racière. Expensive. I just paid the subscription. I don't. Oh, it's done. Oh, what the hell? Type blah blah blah. Yes. Wait. Forward. Okay, so what did you actually do? So here we go. Here's some examples here. It's like Bash, but you have typed pipes. Essentially, you can have typed pipes. So if we echo 21 into parse int, that's gonna turn the string into a integer, and now this function it only accepts an integer. If you put a string in here, it's gonna be a compiler. So that's one of the things in the language, and that doubles the thing. Okay, cool. We parse and halve it. Wait, or did you make those built? No, I hope you didn't make those built-ins or something. It's just an example here. Okay, what actually changed? I'll say there was some bugs found and stuff. Okay, I'll trust you. It's been such a long time since I looked at this code, so I have to trust the AI now. Let's continue with higher order functions and generics. Let's do it. All right. In all seriousness, no. If people want to vibe code. But for me personally, I effectively see this as smart people making smart people dumber, reducing their critical thinking, overall being net negative. I don't think. I mean, it depends. Like, I'm still programming normally while using vibe coding for a project that I'm eventually gonna get like something out of, but I don't want to spend the time actually implementing it. So it's like sometimes it's just like you wish you had this tool, and instead of having to kind of make the tool yourself, you wish you just had it. That's the difference, I think. Like, I do enjoy actually making it as well, but like right now I'm trying to make something else, and in the meantime, you know, someone else, you know, works on a tool that I want to have, essentially. So I think AI can be very good at, like, let's say you just want to make some, I don't know, tool to do something, and I think AI could be good for that. Maybe, I don't know. It's all in a blob, because it's like sometimes it just doesn't do what you want it to do. So then you still have to go in and fix something. But this has worked so far pretty good, I would say. And this is kind of complicated, actually. Like this language here. Yeah, I feel like when I implemented, so I did the base of this language, and then I let AI just implement more stuff, essentially. But then it's grown more complicated. So I don't know if we're gonna reach a limit here soon, where AI will just give up and say, I can't do this because it's too complex now, because I made the code bad, and then I would have to go in and fix it again, because that happens once, and I had to go in and do everything manually. Like I rewrote the whole language essentially. So first, in this project, I tried to make it all through AI, but I was pretty bad at using AI then. But now I've gotten better to use AI. But essentially, I tried to add more features, and at some point it said, like, I can't do this. Okay, why can't you do this? Oh, I need to do this and this and this. Okay, well, do this and this and this. No, I can't do it because, yeah. So it basically refused to help me, and I was like, okay, let me just rewrite the language myself, and yeah. So and then after I got a foundation of the language, then I was just asking, okay, well, can you just implement this for me? And then it's like, yeah, okay. And then it's like, okay, well, this looks good, so let's just go with it. And then I was just rolled with this. It's destroying the planet. Do you mean energy consumption? Or what do you mean? But I'm playing to rewrite wiser because the docs are dog shit, something which shouldn't be dog shit. Do you have to rewrite the whole language to make the docs better? I use AI for writing my commit messages too. Yeah, same here. Although I do not like a lot of text in commit messages, but they have to be very terse. Energy consumption, water consumption, demand on hardware. Yeah, that's true. I mean, I'm not using it excessively. Go on. Prices go up, things getting more expensive. Rudy, did you also vibe code? Did you vibe code wiser? Be honest. Okay. Let's see if we can make this work here. I don't think this will work here. This is the problem. We would have to kind of construct a new... I mean, we can construct a new tuple. I don't even know if you're supposed to put a tuple in here because this documentation doesn't say. You are. So, okay, it's a tuple. Okay. AI is banned in compiler. Okay, cool. It's heavily subsidized. Fairy tales forever after. Should only rich people use AI then? So many wrong with it. It's laid out right now in my opinion. I mean, okay, so without like energy consumption and all that, is it still bad, do you think? Like, is it still morally wrong? Like it's just the resource, like resource cost? Or how do you feel about that? Okay, we have to make a new tuple here to call this function because we need the actual struct itself as an argument. So I'm gonna construct a new tuple. This is gonna be the args type. And this is gonna be a tuple with args fields. And args fields is essentially going to be I mean, it's actually just type of this. Plus type, no, fields of args. Field types. Is there no tags? No, that's not correct. Man, is there no way to get the types out with a function? There's no like type field types function. Man. Okay, well, I guess we'll start with this. We have to loop through all the fields of type of args, type of args. We get the fields, we modify you to be args field plus item. Item is a thing, and you are field.type. And there we go. And then args. So now we have the tuple constructed, and then we say we need a new args, which is going to be an args, and we set it to undefined. And then args 0 is going to be f or closure, and then we loop through the fields of args. Actually, we could just loop through args. Arg. Wait, how do you access the tuple n? Okay, wait. Technology is bad. I think there's a lot of good come for AI in general. I just think the way it's been pushed down on consumers is wrong and merit doesn't compensate for impact on the planet. Yeah, I guess a lot of things that it's being used for could rather be like, maybe it's better if it's used more sparingly, maybe, and not used for a bunch of stupid things, I guess. Have you tried using local models? Quite really good. Local models outdated. Yeah, I've been thinking about like, but I don't know how feasible it is, like buying like a local computer to just have AI on it, like an LLM, and run it on that. How do you access tuple like fields, but you want to wait. So I want to access the tuple field. I guess we would access. Okay, I guess we will do this actually. We would just do for fields of args. We get the field. We skip the first one. If I mean, okay, we skip the first one, we can just do this. Or we can just say 1 here. Okay. And then we say field args field name equals oh, actually we do need index actually. And that's gonna be like fields of type of the original args with index I, and that's the field info of original arg. And then we do at field args field info name. Okay, and then we pass in args there. So yeah, so this function can take a function or a closure, call it with the arguments. It also takes the name of the function name of on the eventual struct that you pass in that we actually have to call. The tricky part was here, like calling the closure function, because it also needs self as an argument. So we construct a new tuple type with self added in at the start, and we also have to construct the actual runtime tuple to pass into here. All right. Kind of messy, but there you go. And we'll see how it works here. Okay, so on start, now we can say stuff here. So we have the argument. It doesn't have to be a function. We will say return call closure on start. Closure is context. No, it's state.arg. The arguments is gonna be game. And there we go. You know what? No. Yeah. No. Yeah. That's fine. All right, cool. So that's on start. And now we can use on start, create a sprite, we return that sprite. We also can, so we can return on start, and we have a function. This is going to be sprite closure, I guess. Function on start. This is gonna take game and self, and we need to store these on the closure. Maybe we can excuse me. Maybe we can even have a function that like creates the closure for us or something. We put the tuple in. It's gonna just produce the arguments. Actually, you could just take a function as an argument, look at the parameters, and then produce a closure type based on those.
But the problem is we also need this one, which we don't have right now. But anyway, okay. That's for a future experiment. Let's just make this work here. So on start, we essentially just create the entity. It's gonna have a body, sprite. No, wait. Box auto position size. I'm just gonna have the default size options. Right. Yeah. This is not the sprite. So, and then we have renderable is a sprite, and man, why is, see, the LSP doesn't work sometimes. The init is like normal, large. Okay, so normal, and then the offset is position. No, that's the offset. The offset is source rectangle. I guess we don't need the actual whole rectangle. We just need the we actually just need like sprite offset, I guess. Yeah. Okay, so we create that entity, and then we also get the entity out. We return it, and that's going to be lifted into the animation monad, and we're going to be able to use it with other stuff. Cool. And then here we simply say, sprite closure, position is position, sprite offset is sprite offset. Great. All right, so now we have stuff happening here. Args fields. You want auto Look at all this zigginess happening in here. I don't know. It kind of, you know, I don't like noise. But this is, I don't know. Once you've gotten used to Zig stuff, it kind of also like, it feels nice when you have this kind of weird calm time magic going on. Sometimes. Okay. Thankfully, you just have to define it once, and then we can use it as long as it works, I guess. Okay, we can also refactor bind to use this one instead now, actually. So bind had its own kind of manual closure here thing, and so here, instead of doing this, we could call the closure instead. Call closure, name is gonna be animation. This is bind arg, and the argument is t. There we go. Oh yeah, and then also we have to set mu to that. Cool. Cool. All right. So now, if we go to the range, this is what we're trying to do. We're trying to define an animation here. So we have a sequence where we have a sprite, that is being created. Also, yeah, I forgot we actually have to you should be a sprite offset instead now. And sprite is just going to be that. All right. So again, we have a sequence. We have a sprite being created. It is then going to call this closure here, which is move project animation. So essentially, yeah, since we need to move this sprite, we're using bind to bind the payload of this into another function, which is this closure here. This closure has target position and speed as state. It has the function where we have access to this information. We also get the sprite that we got from this here. And then we return the animation we want to execute essentially on this sprite. So we want to move the sprite to the target position with the speed. And then when that is done, we destroy the sprite. This is how you should read this code essentially. It's like a sequence happens, like first this happens, then this happens. And that's the animation. Cool. And then here we have like damage number, which we don't have implemented yet. But let's try and see if this works. I've already deleted like the old animation stuff, or commented it out, I should say. I've deleted the system and stuff. So let's now see if we can compile for real. No, we can't. So we have animation sequence 137. All right, what's your issue here? Unable to resolve comp time value bind org. Oh, I see. I thought that you could pass that in and just use its type. Maybe because of this, maybe we have to use like has declaration instead, or we could use like a type of, let's use meta has method. Animation. Comp time value. No, it's still. Wait. If we have the method return yeah, if we have the method return field info type of bind org, the field is animation type I guess otherwise unreachable, or compiler invalid bind org, I guess. Thank you, undeclared. Sorry. Thank you, undeclared, for the follow. Thank you. Zig, cool. Haven't seen the code before. Right. You haven't seen Zig before? I feel like Zig needs to get a popularity push. It's such a cool language. So what do you usually program with? Haven't coded it yet, but so many friends use it? Okay, cool. C++, right? Like game dev, or... That's usually the case. Software dev, really? I guess it needs to be optimized. What kind of software do you do? I mean, okay, fine. Let's just pass in type of bind.org. And then this is a comp time bind.org type instead. And then this is a bind.org. And this is just bind.org. And this is bind.org. All right. That should be working better. I'm not sure what the rules are exactly there, where sometimes it feels like you can do that kind of thing, and sometimes it feels like you can't. I'm not sure why. Alright, so we get an invalid bind.org. I built a workspace manager for Windows. If you ever used like i3 or Hyperland, some similarity, but not quite the same. A workspace manager. I don't think I've used those things. Hyperland. It rings a bell. I'm thinking of like a terminal that's written in like JavaScript or something like that. I can explain, but it's more of a pitch, so I don't want to push onto Zoom. Okay. Well, cool. A workspace manager. I don't even know if I know what that means. Isn't there like a terminal? No. I don't know, man. In C++, you can split your screen to regions or apps or websites, resize them, kind of thing, other features. Isn't that like, okay, so the term that I would think of is window manager. The window, tiling window manager. Okay. Now I see. Because workspace makes me think of like, you know, like Office 365 or like Google Workspace or, you know, company stuff. Okay, cool. Or potentially just multiple desktops, like, yeah. I guess that could be like part of window manager, I guess. All right, cool. I used to use one when I used Linux back in the day. I used to use one that was built in Haskell that was called X Monad, I think. That one was pretty good. Xmonad. I really enjoyed using that one because it was so simple. You press a button and you can change the layout. It like in Windows, every window is floating around. It appears where it wants to appear and stuff like that. But this one was like it had all the layout was fixed, so it's like a window always appeared in one of these slots essentially. And you could like configure it with Haskell, I think. All right, Hovsetter. Thanks for joining. See you later. Have a nice day. All right, cool. I'm not sure, like, is there even are there like tiling window managers for Windows? Okay, invalid bind org. Where is it? Where is this coming from? Range attack 93. So the thing we put in is either a function or a struct with a method animation. You simply check if we have a function that has the declaration and which also check the actual type as well, okay? So it doesn't check like arguments or anything like that. There's a few, nothing as good as mine though. Okay. All right. Now you're getting close to the pitch here. It's fine. I don't care. Yeah, no problem. I'm just joking around. All right. So what do your friends do with Zig though? I wish I had friends that programmed. My friends, none of my friends are programmers. Actually one, but whatever. Let's see. Why do we get this here? Invalid. I guess we could print out, let's just print out the type name so we can see what we're dealing with here. What? Oh, range, move, yeah, so that's what we get, okay. So why is that an issue? Why are you... Because field info takes a field enum, which is animation from type T, which is bindorg, which is... Wait, is it because it's not a field? Oh, it's a declaration. Oh, I see. Wait, can't we just do dot animation like this then? Still? Same issue? Okay. No, it doesn't go into the if. Or it means we have to say comp time here for some reason. Maybe. Is that the issue? No, it's still... I have too many friends that are mostly vibe coders, few are pretty good programs. Okay. Cool, cool, cool. Are you interested in Zig? I guess you are, since you joined this the stream here. There's not a lot of streamers using Zig. Every time I try to raid something, no one is doing Zig. I'd like to learn it eventually. Yeah, I think it's an amazing language. Like it's so cool. Even though I get stuck sometimes on the comp time stuff, but yeah. The more you learn, the less you get stuck. How is it invalid? I don't understand. It should have like the method animation. If has method animation. Is it a typo? Did I spell a typo? Do I have to put pub here? That changed it. It has to be public, because otherwise it won't show up in the other file. Okay, well that's good to know, I guess. But it feels wrong as well. I feel like it used to be like that. I guess it's fine. Does not support field access. Oh yeah, it's just gonna be the no wait, it's just gonna be type of this. Right, there we go. And then we have the same thing here, bind arg function. We have to say type of. This is why I didn't want to do this, because now you have to say type of everywhere instead of just passing it in normally. I don't really get why you have to do this. Because it should always be in a comp time context, because it's always like a type that we put in. Maybe this is what's causing it. I don't know. Animation sequence 1161. Expected 2 arguments, found 1. Context. That is true. I never... Oh, interesting. Yeah, that's bind, right? So we never used bind before, so we get some issues here. 168. Update. Takes the monad and the context returns expected star t, found t. Oh. Sure. Name the content value. Okay, we got the same issue here. So type of, and it's so strange because I'm pretty sure that I used to be able to do this, but okay. Type of, and now actually here we need to do like field info. No, actually no, we just need to do arg. No, that's true. This is correct. This is correct. Yes. There we go. And actually bind can also use that bind arg function. It's like first we get the actual function. It's gonna be closure function of bind arg, and the name is animation. So there is the function, and then this is the return. Wait, no. There's just going to be a function. Actually, this is the thing. It's just going to return this. Yeah. Values must be compiled by user. Okay, inline 4. I guess same thing here. Inline 4. 319. Unable to resolve compiled value. This is a comp time var. $328. No field named animation in component, blah, blah, blah. No field. Oh, right. This has to be type of FO closure. There we go. $328. Expect type entity context found void in args. Hang on. Is this index the same? I think it is. Because here starts at 1 and here starts at 0. So this should be like the 0 index of this one. And the field inf, the name is corresponding to the first one. So that should be correct. This. And the field info name is from this one, which is like the one is your first 0, then 1, 2, 3, and so on. If they're ordered, I guess they have to be ordered. Are the tuple fields always ordered? I guess is the question. They have to be. Actually, you know what? The thing is, like, it's the thing we put here is wrong type. That's the thing. It's the wrong type. Not. This is just creating the values. So the type is wrong. So the field starts out with this. And then we go through each field of args. And we add it to the fields. Field.type, right? That should be correct. I guess we could like log out. Calling. Let's do like this dot this, which is type name, type of f or closure, and then this would be f name, and then this would be the arguments. I'm going to put the type in there, see if that. No, it has to be like, hang on, compile log, and this is comp time print.
calling components, range attack, blah blah blah, animation dot animation, struct components, animation void. So the type is actually wrong. Why do we get void here? So we loop through all of these. The arguments is void. Where was that called from? Here. Oh, whatever. It's not used. So we get, this is the tuple. Oh, I see. I see. It's this one. Right, it's void. Yes. I guess if it's void, do we even add it to the thing? Maybe we don't even add it. If it's void, we don't add it as a argument. Perhaps. Not sure. Actually. Expected enter console file void. That's so strange though. Why? Like that kind of tells me that, does it actually expect? Wait, it's not void though. It's not void. It's actually... Yeah. So if I do a compile log here to say bind payload is type of T, right? Then we should see a compile log that says bind payload is what the hell is this? What is this? As construct comtime. What is this? Star const? Oh, that's a type. Equals what? Wait, what the hell is going on here? Oh, it's a tuple, right? But why does it say equal? Oh, that's the default value. Okay. Oh my god, that was so strange. It's a tuple that says void. Because that's the type name of void, I guess. That's so weird. I've never seen that before. Why is it void? It shouldn't be void. It should be the return type. Hang on. So wait, no, it's T, right? It's gonna be the payload of this. So it's gonna be, it has to be T. Wait a minute. No. The monad doesn't have to be T. Actually, we don't know the input here. We don't know what this is. This is any monad. Yeah. Okay. So we still have some type stuff to work out here. So, right. So MT is just type of monad, and T is, I guess it doesn't really matter.
This is just type of monad. Right. Okay. And then down at ranged attack, we get a sprite. Okay, now is the issue here, because we can't simply say dot sprite. This is the issue. This is what I didn't want to happen. It's like, yeah, bind knows that we want to get a monad. But if we can't just say dot sprite here, because now we don't know what the type is anymore in bind. So we don't know that we're working with a monad. And we can't just say, you can't like constrain it. You can't say like animation monad, any type. Like this doesn't work. I wish it worked though. Now what you can do is you can say com time, you know, t type, and then this is a monad t. That is possible, but it's annoying because now we have to specify what we get, which is an entity context. Come on. And now we can actually pass sprite. But again, it's like annoying. I don't want to have to do that. Man, it's so close to get that working. I guess for bind, maybe it's acceptable, maybe. I don't know. Okay, let's do that for now, and we'll see if the whole thing works anyway. Unable to resolve com time value, right. Com time arg type arg type of arg type of arg. Hello, Pandoro. What's up? Welcome. Hi, how big is your monitor? Try to upgrade from my 22-inch. I don't know. It's like so the monitor, like it's larger than what you see on screen here. I have like a wide one. I don't remember exactly. I do not remember exactly which one it was. Let me check. So I have see if I can get this up here. Okay, I have this one, which doesn't, I guess it's like outdated now. It's 34 inches, but it's like a wide, so it's, yeah, it's a wide one. So there you go. That's my monitor here. Samsung LC34G55TWW RXEN. All right, we'll see how much time I have now. I don't know. I think I'm on borrowed time right now. Let me check my messages. Okay, there's nothing here. Okay. Cool. All right. But yeah, I could be aborted at any point in time here. But anyway, let's see if we can make this work. What's the issue now? 378. Return entity. Oh. Okay, now we're getting stuff here. Value ignored. What? Oh. Oh yeah, we need to return this as well, right? That is right. There we go. Expected animation monad void found animation monad entity context. Interesting. Right. Because that's what you should actually be. Oh, we have no destroy. Okay, there we go. Now we need the destroy as well. So let's do destroy. I guess we have the entity. And this gives us a void monad. We have to store the entity here. And we can... Now, the thing is, like, it would be interesting. If we could, like, let's say we, in this monad, we introduce... The interesting here is, like, you can actually introduce state in the monad to, I guess, more simply do these things as well. That would be really interesting. But I think that if you introduce state, that's going to be like, the thing is, I'm just, I don't know. It's going to be very interesting, because then you would, instead of binding the sprite, what you could do is you could say sprite, or you could say let, you know, projectile be sprite, blah, blah, blah. Okay. And then instead of bind and do all that stuff, you can like move, and then you can do like, and then what you want to move is going to be like an expression instead of the actual like entity context. You're gonna get it. You're actually gonna have an expression here, which is like identifier projectile, and then continue. So you can do whatever, you know, what is the target position or whatever it is you want to have here, and then the speed. Yeah. So there we go. Now you can, like, we can kind of avoid having this whole closure thing. And if you could do this, then you could potentially do that. The problem, I guess the problem here is like, well, both the implementation of it and also like essentially how do you avoid having a bunch of globals that you might, you know, pollute or whatever. So yeah, but that would be kind of cool to have this kind of little. What you could do, maybe you could have like, okay, we have a scope, and in the scope you provide a monad. So this monad would have its own scope, and everything that is, so it's like a local scope. So everything that is defined in here will get released at the end of the scope. That could be kind of cool. Okay, well, enough of that fancy fantasy land here. That will be. I think actually, you know what? I think that's what we want to do. Not right now though, but it would be so cool if we could do it, because we could just. It's just a way that Zig kind of deals with closures and stuff like that. It's just so messy. So maybe that will be like the solution to that issue. Essentially, we could. Yeah, we could do all sorts of fancy stuff with that stuff. All right, cool. Okay. The problem also is like, okay, but what type is it? Like, we probably, like, in the identifier, we probably need to specify the type as well, because then we would probably have like different stores depending on the type of what you would want to put there. So yeah, so you would basically have a hash map that is the scope, current scope there, and I guess the scope would be like a scope stack, and then each scope in a scope stack would have, like, I guess a bunch of different hash maps, I guess, depending on which types you registered. But then we would have to kind of com time know which types we need to have, though. I guess maybe we'd have like one scope per. Yeah, that's the thing. Then we would. So it's kind of difficult. Otherwise, I don't, because you can't store the type with the value. That's the thing. Unless the only thing we would allow would be like an entity context to store. That could also be a thing, like use or some kind of value that is generic enough that we could do like put anything in there. Yeah, something like that. I don't know. It's doable, but it has some it has like some cons as well, I guess. Okay, so destroy. Right, I just copied this over. Right. So destroy has an entity. The closure has an entity. This should be called destroy instead. Return on start. We have destroy closure. Maybe we should just start calling it closure actually. And the closure has an entity. That is the entity. All right, and we have, this is going to be void. And we don't create an entity. What we do is we just call destroy on the entity itself. And there we go. And you are unused, so we don't care about you. All right. Cool. And that's basically destroy. We're using the primitive on start to basically, yeah, just call this closure here. Yeah. All right. Cool. So that should be that. All right, this has to be called on start. I forgot about that. 166. Oh. Now we get these. 329. Let's get rid of these comp logs. Are we done? Are we done? We are done. Okay. So, and there we go. Did you see it? We got the range attack. It spawned a sprite, and it destroyed the sprite when the sprite was done. So it works. Not sure why we still get these rectangles. But hey, it works. Awesome. All right. So what we're doing here, again, if I go through this again here, is we are we're creating a animation monad, and we're binding. Yeah, we can bind, so we can have a a sprite that we create. So this is an animation, right? It's a sequence, and we create a sprite, which we then use. We bind it into a move animation, which is a closure. So there's some different kinds of things going on here, but it's like, and then this is an animation. It basically is another animation which it just moves the sprite over to target position and then destroys the sprite afterwards. So it's kind of like a system to more, I guess, instead of having to manually do all these animations, we can now use this system to create more like animations more easily. And if I wanted to create like, let's say I want to create like multiple, let's just test this out. So basically, let's say we want to do this. Let's say instead of we have a sequence here, let's say we have a parallel, and we do this again. And this time the target position is going to be like plus, I don't know. Let's do like, let's do like let's do rotate. Rotate 1 0. Or actually, let's just take rotate target position by some amount, like I don't know, some kind of degrees, like over 8 maybe. And then we'll do another one where we rotate the other way, so negative 0.0, because otherwise something goes wrong. Okay, so now all those should like happen in parallel now. Okay, so if I go up here, I go to someone who wants to shoot me. Okay, I'm not sure where they're going. Oh, wait. Wait, we rotate target position. We should rotate it so the right. Actually, this should be relative. Yeah. We need to rotate the relative. The relative is let's see, we want to flip the target, right? So that's going to be attacker position minus target, I think. Wait, is that correct? No. The relative. We will rotate the relative. No. It's gonna be attacker position plus. Yeah, there we go. Attacker position plus. Right. We get new target locations that has to be offset from the attacker. That's right. All right. Let's see that. Thank you, Phil. Okay. Let's see now it works. Huh. It goes like up. For some reason. I'm not sure why. But there you can see kind of the, the details of the thing, but you can see how the animation system works. If we now change this to a sequence instead, it should play those in sequence instead of like everyone at the same time. So there you go. Now it's playing it in sequence. There. And those animations play at the same time, but they are part of the same animation tree, because we gather up all the animations and then we put them in a parallel. So all animations are like gathered up, put in a parallel animation, and played simultaneously through the same system. So yeah, that works really well. I mean, if let's say they do like a double attack. I'm not sure why this rotate didn't work. Maybe I need to, maybe, okay, the relative is probably the same. We have to do the other way around. Yeah. And then let's do this in parallel now. So it's gonna be, because what I wanted to do was that they shoot like 3 arrows. Yeah, like that. Exactly. So there you go. So that's what you could do, and then it's like, yeah, you can repeat it. I guess we could probably add like a repeat. Yeah, that's actually pretty simple to add like a repeat. Repeat primitive. So if we do, let's put it here. Let's put it here. And I'll just gonna take this probably. And we'll do like repeat. Because that should be like a primitive. We can also have timing based primitives where it's like it's gonna wait for some amount of seconds. You can have like a pause, whatever you want, essentially. Repeat is gonna take a monad, essentially. I mean, I guess it could be the same type that we want to have, I guess, maybe. Yeah, sure, let's do that. And then this gives you a T as well. We could potentially put like get a list back, but nah. All right, so this one would now have a repeat state where we have the monad. Monad is, well, let's move this type into here actually, because it's gonna be type of monad. All right. And then this is called repeat state. So we get that state. We will basically we run this monad, or we execute it. We call update with itself and the context. Okay, if this returns a value, we get a payload. Then we would actually have to keep track of how many times we've repeated this. So repetitions is repetitions is plus equals to 1 if repetitions is equal to you know, how many times we need to repeat. So repeat repetitions, I guess, usize. Actually, let's do -1. So we start out at that, and then if we're at 0, we just return the payload. But otherwise, we keep going. So we keep repeating until we reach 0, and then we're done. Okay, and so we need repetitions here. That's just a U size. It's just gonna be repetitions. And there we go. And then we initialize. We are going to have the repeat state. And monad is monad. Repetitions is repetitions. I guess, does it work with default values? I don't think it does, actually. I'm not sure, actually. Can you actually have the default values straight here? Because now you don't need to... Then you can just do this. I don't know if that works. We also have to... we also have to use it, so... so let's say instead of doing... well, let's say we want to repeat everything. So we just repeat like 2 times or 3 times. Alright, so now we're repeating it 3 times. Well, if it works, that is. 211. Yeah, okay, so you can't do this. Okay, fine. Fine. But we just do this then. Okay. This should work. Oh. And it actually failed. Oh, you know what? This is actually interesting. You know what? Repeat is actually more complicated. Yeah, I just realized. Because once an animation is done, it kind of enters like an invalid state. So in order to be able to have a repeat, we would have to have a concept with like being able to reset a monad back to its initial state. Somehow. I see. Yeah. Because otherwise it's just gonna... This monad is... Well, potentially what we could do is we could just store the original monad here. Maybe. Is that enough? No, then every monad has to implement this functionality, actually. Because even if we restore this to the original monad, we restore this to the original monad. Well, as long as we're not working with pointers, I guess it actually just copies everything. Alright, so we store the original. Let's try it, I guess. Original is just a monad. When we're doing a repetition and we are not returning, then monad needs to be reset. So we set it back to the original. And now then all that state should be updated. It's just as long as the implementation, we have to make sure that all the implementations of the monads do not include like a pointer to something that changes state that we need to worry about. And I think that's exactly what we have here. Actually, we have like animations is a list. This is actually modified. Yeah. But hang on. When we create the thing, it's duped, right? So we get like, we keep the same duped thing, which is gonna get changed, right? So that is exactly what this is doing here. So, perhaps if we, so then we would have to like introduce like a reset implementation function actually. I mean, I guess we can. It would probably be good to have, since it's an animation, right? So we probably would want to have something like pause and maybe, I don't know. Okay, well, we could just do a reset. You don't return anything. We don't really need the context. It's just gonna be this, I think. Do we need the context? I mean, I guess we could have it there, I guess. And then here we will have it again, and then reset is reset. All right, so because it's basically once a monad has been played out, it's essentially consumed, since it's like a stateful monad. That's the thing. So actually, I wonder how that will work with like stateful, like scopes and stuff like that. I guess resetting a scope would just clear it. Yeah. Yeah, I guess. Yeah. So now basically we have to go through all the primitives, and we have to implement the reset function. So offensive. Hello, Vincent. What do you mean? Reset is essentially just a no up here, because we already, like, we don't need to do anything. But I mean, the thing is, like, with reset is like we just need to make sure that this value is like not actually modified. It needs to be like a pure value that's not modified. So maybe it actually needs to be like a const, to be honest. But it could still potentially contain pointers to something that can be modified. So it's like you're never safe, you know. Stateful monad, yes. I'm cheating here a little bit. I mean, a monad, as the state monad is a stateful monad. So, but it's more like, well, yeah. So it is a stateful monad. Yes, there's nothing wrong with a stateful monad. And in fact, it's actually good because it allows us to do things that is good. All right, so you don't need to do anything. Do is just a side effect. It doesn't have any. It doesn't do anything. Emit global is a combination of things. Emit is also same thing. Bind is very much not a combination of things. In terms of primitives, it has an update and a reset. Now I guess the reset here would be essentially we get the state, and we set mu to null, back to null. Right, and then this monad, I guess also, like, if we have an mu, no, because we're gonna get a new monad out of the thing, unless it's a constant. No, it's not a constant. It's okay. No. Yeah. Unless it's like cached. It's not gonna be cached. Mutate all the monads. Yeah. I don't think we need to worry about mu, because it's gonna we're gonna produce a new mu when we call the function here, as long as this result is not like stored and like, oh, like it has a lifetime. It's more like we just produce a new monad. Yeah, I don't think it's an issue actually. So the reset will set you to null, and it will reset the monad here. And I guess we'll pass in the context as well. All right. Cool. So that's bind. Sequence. Yeah, sequence have to reset every inner monad, so that we currently have. And it's the same thing. We get the sequence state. We will set index back to 0, but before we do that, we also have to reset every monad inside up to index, I guess. +1, even. Let's just reset everything, I guess. You have to be pointer. There we go. All right, and then we have repeat. Same thing kind of here. We will reset the monad. But, and then we don't need to store the original here anymore. All right, cool. And then also here is like, instead of doing this, we would call reset on the monad itself. So there we go. Parallel. You will wait. They shouldn't return that. You on par state. Kind of same thing here. Let's just loop through the animations and get them reset. Wait. Oh, hang on. Wait. Okay, this is different actually, because it's kind of mutating this list. We need to keep the original list of animations as well. So original is we're gonna keep the original around. I guess we have to dupe twice. Then you know what? Instead of this being animations, we could just have them be usize into the original. Yeah, let's do it like this, because then we don't have to. But then these need to be mutable. Yes. So we have the duped animations. It's going to be animations. Let's call these animations actually. You would be like animations index, and you would be the animations. So animations is equal to duped animations. The index is just going to be empty. No, it's not empty. It's going to be, yeah, animations index is going to be like array list use size init capacity, I guess. Animations length. And then I guess we'll go through. We get an index, animation index. I equals I. And we have to also populate it Or, I mean, we have to say something capacity. Expand to capacity. It's just setting length to capacity. Thank you for the follow, Drain Yard. I think it says. It's kind of hard to tell. I might change the color of the font there. It's hard to see. It's kind of small as well. But thank you for the follow. Welcome, welcome. Reset context. All right. Cool. So we dupe the animations. We create the indexing. We expanded capacity. We populate it. We should also pass it in here. There we go. All right. So now when we reset, we go through not the animation index, we go through animations to get the animation and we reset with that. There we go. And the parse state is correct. We don't need this, I don't think, anymore. No, that's not even used, so we don't need to worry about that. Okay, so we'll remove things from the index now to say, okay, which ones are done playing, essentially. And if we're done playing, that means we have no more items. Then we're good. Then we're done with the thing. Also, we could simplify this a little bit, but let's see. We get the animation. This is not correct. This is just the animation index. And to get the actual animation, we would have to go to state animations, animation index, get the pointer, and there we go. Okay. And you know what? Let's do like a buffer here. This is a buffer of usize with animations length. Wait, can you do that? It has to be comp time known. I don't think it is. I think most of the time it is, but we could potentially put a runtime known thing in here. No, I don't think so. Whatever. Let's just do it like this. All right. Right. So the whole thing here, we want to be able to reset these animations. So reset would simply go through all animations and reset them. Now we no longer have a mutable list that shrinks. Well, we do have here though. So we have to kind of recreate this animation index as well. So we have to kind of do this again. Except we don't need to initialize capacity. We just need to do this part. So let's just do that. All right. Wait, no, we do need to expand the capacity because it has been, we have modified it. Do we need to ensure capacity as well? Probably. Let's ensure total capacity of state animations length. No. There we go. Okay. Right, state. All right. Okay, so now we should have a repeat 3 possibly work. Wait, I might also need to implement this for other stuff as well. I was like, am I getting a call or not? I'm not. It was just freaking out. All right, so that was reset for par. What other primitives do we have? Move. Needs to be reset as well. We will say move state. And what do you have? You have a bunch of stuff. I guess the move state kind of like it should it move the body back to where it was? I don't think it should actually. The move, it should have moved the body back, right? Because the move is kind of like, it's seen as like a yeah, it doesn't make sense. It's seen as like a relative move towards some position. It's not a relative move, but it's like a move to this position. And then you're done. If we all of a sudden reset, it shouldn't replay that same thing. It should just keep moving. That's a decision that I'm taking, essentially. So yeah. Also, I think we call initialize. That will set steps and move step to what they were before. Move steps. I guess steps is the only thing that needs to be reset, essentially. Because I think that's what gets mutated. Maybe it would make sense to have one portion of the thing that is like mutable and one portion of the thing that is like immutable or something. I don't know. But I don't know. Let's just call initialize on the state. That would kind of reset the state here, essentially. So yeah. And that's it, I think. Yeah. I mean, we could even just say is initialize is false and then it doesn't matter. Okay, so I think that's actually it. The only thing we modify is the steps. The steps just, but the thing is we don't know the original steps number, so we have to like recalculate it, but that's fine. And this is not a higher order monad or anything, so we don't have any monads to reset there. All right, let's continue. And what do we have on start? I don't think you need to do anything, to be honest. On start, it just has like a closure on it. It's if the closure gets modified, maybe. That's not gonna happen. Hello, Packrap. How's the progress? It's going good. It's going good. I'm currently expanding, like, or working on the animation monad a little bit. It does work. So it has a bunch of work, but it's like I'm just expanding on it a little bit. I'm adding like repeat repetitions, basically loops, essentially, maybe you can call it. Not really loops, but more like a repeat where, yeah, you can repeat something multiple times, essentially. Yeah, makes sense, right? All right, so Sprite just uses onStart, so this doesn't actually need to do anything. The only thing is, like, I guess if you repeat a sprite, it would create a new entity, but that is correct, right? That has to be how it is. That is also what we want, right? Destroy is like repeat a destroy. I think this doesn't make sense to repeat a destroy. I don't think in this case it will be an issue. We could add a guard here to say that, okay, are you valid? If you're not valid, we will not destroy you, because then that will, because crash essentially. Can I see the art? Yeah, I'm trying to make it. I'm trying to make this run, and then we're done. Okay, I'm trying to make it compile here. The sequences, yes. Okay, what the hell? What's your issue? Expected 3 arguments from 2. Oh yeah, we actually have to pass in this everywhere now. Oh yeah, and the signature was wrong on a lot of these. Possibly most of these, actually. Shouldn't return anything. All right. Let's get this compiling. 212. Expected 2 arguments, found 1. Oh, because it's a... Alright. It's a field, not a function. Yeah, same thing here. Except here we need to do that. 253. All right. Oh. What's happening? There we go. So here's the art. It's a downloaded tile set, but I really enjoy this tile set here. Okay. So let's see. Well, the move still works. So what would be the difference? The difference would be the ranged attack. I'm kind of like trying out the animation system that we're having. So we have these ranged goblins here, and there we go. Now it's repeating 3 times. So boom, boom, boom. This is the animation system. I'm kind of trying it out. We're spawning like 3. So basically, how this looks in code. I'll go to range attack. So we're repeating 3 times. We have a parallel animation here, which spawns 3 different like projectiles, and that's it essentially. So we calculate where should they end up here. So this is the animation here, and then you can. I mean, I guess you can like repeat again, repeat 3 again. As long as everything is following the like monad rules. It should work, you know. Where's the range? There's a range 1. Okay, something happened. Interesting. Integer overflow. 239. Oh, I forgot to implement reset. Well, I did implement reset here, but I implemented it wrong, because we have to restore the repetitions back to what it should be. I see. Repetitions should be equal to, well, okay, we have to restore the original repetitions. Repetitions. How do you spell it actually? Repetitions, right? So we have to store the original repetitions so we can reset them back to what they were. Cool. Let's see if that works better. That works better. And now it's gonna be like, you know, 9 times 3, 4, 5, 6, 7, 8, 9. So it's like if you have a machine gun, you can just repeat a bunch of times, and you can repeat the repetition. Also, like you can go, let's say we try like move, for example, the move animation. Right now we just move, you know, it's just move once. But let's say we want to repeat this, repeat 3, move. That should move like, you know, in the same. Actually, this is kind of stupid. I just realized, because move takes an absolute position, so it's gonna move to the. It's just gonna not do anything because you're at the position we need to move to. So it's like an absolute move. We need like a relative move for that to work more better, how I thought it should have worked. So actually, you know what? We could have a thing here where it's like move arg, I guess, or init. Move init. Sorry about that. Move init is a union enum. So you can decide here. So you can say like, I want this to be an absolute. Then it's just a vector, or I want it to be relative. And then we have absolute function takes a vector. And this is the position. Turns a this. Turn abs is position. And then we have relative. And this will be like the delta. All right. So then depending on the move in it, we will move to different places. So, or we will, it's gonna like, we're not simply moving. Well, I guess we still have a target position, but the target position is gonna it's gonna like depend on the current. So actually, instead of setting target position, we're gonna set the move arg actually to move arg, because we need to kind of keep that in. We need to have that there. And then let's see. So your move arg, we still could potentially say target position is a game vector which start out as undefined, so we don't know what it should be. Initialize should actually like calculate the target position. So that's the thing now. Is actually, that reminds me, the reset should then actually not call initialize, because it determines at the start of the animation we should determine where to go. So I'm just gonna call set is initialized to false. That will reinitialize whenever the animation is supposed to start again. So there we go. Okay, now initialize will calculate. So this is the current position, and then the target position is this. So target position is going to be So this is depending on move arg. So if move arg, if it's absolute, then we just get the, it's just going to be the absolute position. So you are going to be target position, and then down here we're also going to set target position equals target position. If it's relative, we actually need to say relative plus the current position. Okay. And now we have some places we need to change, which, whoops, over here, for example, move. Let's move. So the position here would be relative, let's say. And instead of this being a position, it could be like a direction. And then this would be direction. No, a board vector. Move. I guess move relative. So that would give us the relative board vector. We need to also like times this by the tile size to get the pixel number. I'm also gonna have to do from int on you. There we go. And now this would be move relative. All right. We could just say, so we have 2 board vector. We can also say like 2 v2 as well. So 2 pixel vector, whatever. And then this would do the same thing. It's essentially like from int self 2bv times game tile size normal. All right. So then we can just use that instead, and then we do like direction to v2. All right. So that gets repeated. We'll repeat move 3 times. All right. Let's see if we can make that work. Hello, Blue. What's up? What's up? Welcome back. How's it going? Right, and now we have other places we need to kind of do the same thing. Here we actually have a half target position. We don't really need to, well, then we don't need to add the original position. We just need the relative over 2. And then this would be like half relative. And then you would be relative. I could just use absolute. But I think relative makes more sense, like in my head. We need to move this amount relatively. It depends on what, I guess it depends on what data you have available, I guess. Target position is, yeah, so we know which target we have, not which direction it is right now, I guess. Well, actually we do have the direction. Okay. So I guess actually, let's just pass in the direction again. And then we don't even need the original position. We have relative, it's just going to be direction to v2. So there we go. Oh yeah, we need to move back. I mean, let's just move back. Okay, and then in range, wait. Oh yeah, now we need like direction. This is gonna be self direction. We don't need target position. And okay, we get something here. You are move in it. You are F32, right? Oh yeah. So in the end, I guess we set to the target position. Yeah. $396. There's no member name abs. Oh yeah, underscore. Sorry. Okay. Okay, now we're move 27. Oh yeah, you need direction now as well. So direction, we don't need target position. Good. A little bit simpler there as well. Okay, now we're in range attack. So I was expecting this error here because we have a move here as well. And this, I guess this would be like absolute. Because this thing is gonna get spawned and this is the only thing that's happening here. So it makes sense that this would be an absolute here. And we're not repeating it anyway, so. So there you go. Now it's like I'm kind of showcasing this here. It's like we're repeating. Now well, I'm not actually out there. The board state is actually different than what you see on screen now. Because we're moving like... Why can't I move? What's happening? Oh, I see what's happening. I see what's happening. I can't actually land on the going out. But anyway, there you can see. So now we're repeating the move 3 times. But it's not actually removing the board state. We're actually standing here now. It's just the animation moved over here. Because the animation does not reflect the actual board state. Which makes me think, maybe at the end of the animation, maybe we should like go through every entity and like move them back to where they were, like their actual position where they should be, just to not have some kind of weird desync going on in the worst case, maybe. But funnily enough, the body is what's used to detect if we're going into an area. So if I go down here, we still go into this area. Okay, anyway, enough of that. We don't want to repeat the move 3 times. It's just going to happen once. But now we've kind of tested it around a little bit. And yeah, it looks good. Cool. And we did the relative move. Okay, what do we want to do now? Do we actually want to get into making a scope in the animation system? Do we want to go crazy? So basically, what I'm thinking is instead of all this crap here, well, this still happens, I guess. I guess we can still repeat and stuff. I will, let's remove one so we can kind of see a little bit more here. So potentially, Yeah, so okay, so what I was gonna do is like potentially instead of having bind to sprite and all that, what if we make a state monad inside of this monad, right? So what does that mean? It kind of means I want to build into the monad, I want to build a state as well. No, not zoom in. It's a programming scope is what it's like a identifier scope. So basically what I want, the code that I want to have instead of this, let's make a new version here of this code, is the input should be all the same here. But here, let's say we make a scope. All right. We make a new scope, and then in here, instead of doing bind and all this crap, what I want to do is I want to kind of, I want to let projectile A equal this sprite, and here let projectile B equal this sprite. And then we have a function. Wait, how will this work? No, yeah, because then we can, let's say we edit move a little bit. So move, instead of taking a just a parameter here for the entity, it will actually take a monadic value as the entity, right? And so in that sense, we can actually supply an identifier projectile A here. So now we're moving projectile A. And we're moving it, whatever we had here for target position, speed. Right, so this would be like absolute target position and then speed, whatever. And I mean, technically, these could also be like monadic values that you could potentially get. But I'll leave that for now. It's not necessary. Okay, and then we move, let's say, projectile B to the other position, which is this position here, which I'm gonna say target position B is equal to that. So this will be target position B. Okay, so basically this would make it so we can do this. Oh yeah, I forgot one thing. Actually, these have to run in parallel, but then we have these two have to run in sequence. So we'll do a sequence here after this has been run. After the move, we destroy the projectile. Okay, and then we have the same thing here for projectile B. Okay, and in fact, this could also be this thing can be kind of extracted into its own function. We can have a function which like move and destroy projectile or something like that, or move and destroy, and it's going to be like monad. This is going to be like the entity, like monad entity is animation monad, and we get an entity context from the payload, right? That's important. And then we have the move in it, I guess. This would be like monad void, I guess, move in it. I don't think we have a way to get it yet, but I'm just demonstrating here. And then we have the speed, which is F32. So this would return an animation monad of void, essentially, because we don't care when after it's been destroyed here. All right, and then this would return this here. So, and then the identifier, no, yeah, then we don't need the identifier. We just need to put this in here and then move argument and then speed. Oops. And then you would be entity. Yeah, move and destroy. It just combines move and destroy. And then, so then we can do like, instead of this, we would do like, you know, move and destroy would be identifier projectile A, absolute target position, speed, and then we move and destroy projectile B, target position B, and that's going to be the same thing there. So here's a pretty simple, because we're creating two new things, A and B, inside this scope. Once this scope gets out, A and B are like, they are locals, so they won't exist anymore. So we don't pollute like a global scope. But essentially, we produce A and B. We will be able to refer them through identifier, and now we don't need bind anymore because we're basically programming within the monad. Essentially, we're binding this to a new thing, and then we're binding this to a new thing, and we're using identifier to grab that out of the current scope and moving and destroying this. So this would be the equivalent of what we have up here, except it's like way less stuff happening, and you don't have to deal with bind, which is a very good thing to have. But it's I would rather, if we have this, I would rather have this than this. So that would be really cool. And I'm actually really eager kind of to start working on it, actually. The only thing that I'm thinking about is what kind of things can we store? Like, can we store anything? I'm almost tempted to only allow this type for now, because then it will be super easy. We just need a hash map of you know, a string to this type that we want to store in a scope, and then we have that on the context. We need a for this, and we can start with a global scope. That's fine, because every time you do let, it's gonna redefine the variable essentially. So we don't even need scope to start with, but it would be cool to add it. If we add scope, that means we need a scope stack that when we exit, when it's like done, it's gonna like, it's probably not that difficult. Oh man, I'm saying that now before actually realizing how much work this is. But we could start with that super simple version, and that will solve this issue for us, because this is the problem we have right now, and we can solve it by just, with those limitations, it's gonna be pretty simple. Famous last words. So let's do it. Okay. So basically, in the context, we would need a scope now. And what is the scope? The scope is going to be, it's gonna be, wait, what's this? We're gonna have a map, which is the, this is gonna be like, what is this gonna be? Like an auto hash map of string Actually, there's a special type for that. So a string hash map, and the value is entity context. See, that's the tricky part. It's like if we're gonna be able to store different types, now that's an issue. If we only allow one type, it's fine. There's basically no issue with that. And yeah, and then we have like init here, init function. Oops, this return map equals init, and then we have the arena allocator there. Cool. So that's the scope. Let's have a function let. Identifier is a string, and then the value is entity context. We can even have like v is entity context, and then we can, like, you know, if we wanted to change this later, we can have it a little bit simpler. I guess we can have k as well. It's just a string, so we can type this out a little bit shorter. Now let doesn't care if something happens. So basically, I think we could just use put. We need self, of course, as well. We could just use put. That will like overwrite the data, and if it doesn't exist, we just add it. If it exists, it's just gonna overwrite it. So there we go. All right, so that's let. That was super simple. And then we have like, I guess we can have like get maybe. This could potentially be like a runtime error. You try to get a thing that doesn't exist. That's gonna be like a runtime error. So let's do like an optional v get. It doesn't even need to be mutable. We will get, yeah, it's the same thing. It's just get, it's just a wrapper around get here. All right. And yeah, and we don't even need to deinitialize because it's part of the arena here. Cool. Excuse me. You know what? Do we even need a scope stack? I think we need a scope stack because otherwise you can't refer to things from outer scope, I guess. All right, but anyway, it doesn't matter. Let's do the simple thing first. I'm gonna do let. So also scope is gonna be init here. Let's do let. Bless you, my lord. Thank you. Let's go. Where is let gonna be? Where do you want to live? Here? Below bind. So let identifier be a value. Is the value monadic? Yes, it is. It has to be monadic. So it's like a monadic value, and it's an animation monad of some kind. It doesn't have to be T here. It is any type, actually. And this, but the whole thing would probably be a void. It's just a binding. Okay. Cool. And then we need like implementation and all that stuff. Let state, we need identifier. Do we need to dupe the identifier? Usually identifier is like comp time, and we should mark it as comp time to make sure, because otherwise it would like depend. We could dupe it as well. It's really not that big of a deal, I guess. So this would be like arena allocator dupe u8 identifier catch unreachable. All right, and then we also need the monad. All right, cool. And then this would give us let state, and we need to reset the monad. And we also, yeah, that's it. I think that's all. That's gonna actually no, that's not all, because we also need to kind of remove, I guess. We like remove the scope, like the identifier from the scope, I guess. So we also need remove here. And we don't really care if it's added or not. You need to be mutable. Wait, where are you here? All right, so yeah, so then we do like context scope, remove, state, identify. Cool. And then update is essentially this could have been a bind, I guess, into something, but now that we're in here, we can just simply implement it here. So this would be, well, we need a state, and we need to run the animation. So state and value, update, context. If we get the payload, we will now return, but we also need to store the payload in the scope. So we need to let the identifier be the payload. And actually kinda this, we know that we actually know the type of this, because it's always gonna be this type right now. All right, cool. And we need like the state type. So let state is equal to mValue type of mValue. And we need identifier is, well, we don't need to equal it. It's a string. We need the type here. There we go. Cool. So that's it. I mean, yeah, we're just waiting for this monadic value to give us its payload. Once we have the payload, we bind the identifier to that payload, and then we're done with this kind of step. Reset will remove the thing from the scope and reset the inner monad as well. I guess that's it. So now the other thing that we need is identifier, which is going to give us, you know, a way to kind of bring something out of the scope. So identifier. The problem here is now we actually need to rename identifier everywhere, because it is a shadow. The shadow. All right, and then this gives us entity context. And then this would be like identifier state. Do we even need a state? I think, yeah, we have to have a state because we have to store the identifier. Yeah. All right, and then let's figure this out. Identifier state. Identifier is going to be dupe. Identifier. All right. So how is the implementation here? The implementation is simply when this gets called, we will reach into the context and the scope. And now it's like if, I guess if it doesn't exist, what's going to happen then? Do we wait until it exists? Because potentially you could have a parallel animation that acts. I mean, that's actually kind of cool. It's like if a variable is undefined, like if it's not defined yet, then this could like wait for that identifier to be defined. And once it is defined, now we can use it. Because that's essentially, we just need to return this. And then other animations could be run in parallel because it's a scheduling system. So let's say you have another parallel animation running, and once that animation is done, then it's gonna create what? Okay, but that kind of goes. It kind of, you know, it kind of goes against a little bit of how we want this to work. But I guess it could be a nice way to kind of get out of the nesting structure, maybe, of the whole thing. So in like an inner kind of loop somewhere, or an inner animation somewhere, you then create a sprite to continue the animation down there. Except it doesn't really matter because you can still... No, that doesn't make sense. I think it's just going to be a compiler actually. Because you would have that functionality anyway with sequence and stuff. So yeah, I think it doesn't matter that much. It's just like how you would want to do it. I guess this is one way to do it. Yeah, let's just do it like this, I guess. Also, this is, we have to get the state. This is identify state. And this would be state.identifier. All right, and then reset. I don't think reset does anything actually. Reset in this one. We're simply waiting for the scope to get populated, I guess. Okay, so that is our new primitives. Cool. And now I guess we'll remove this and we'll try this one. Because this should work now. Except it doesn't, because move and destroy takes like actual entities. They don't take monadic values. We have to update these to take monadic values. Also, we don't have scope, so I'm going to remove that. But these should now, we should change these to actually take a monadic value here instead. Yeah. So you know what? This is actually just a bind, to be honest. Right now. We don't do any fancy stuff with like the inner workings of the monad here. We could just make this a bind actually. Okay, well, anyway, we have the move thing, the other ones doesn't need to be in the monad. This would be an animation monad of game context. And then that is what we need there. Except we probably don't need this stuff. The only thing really, we need like a reset functionality for the init. Yeah, because it could rely on... But what if we bind, what would that entail? Maybe I shouldn't think about that right now. Let's just do it right here. Because I'm pretty sure, I think binding it is more... That is probably how we want to do it later. But for right now, I'm just gonna expand this implementation here a little bit. Now, yeah, this is the thing. These are like the initial arguments here, except for this one. These are the initial arguments, and then these are like the mutables. Like when we want this animation to play, these will get populated. This is kind of like how I'm doing this. So we actually will get the movie at some point, right? And then we actually have to change you to be movie here instead. So there we go. And which means that we actually cannot, we're not really initializing the first thing we do. We have to wait until we actually get the movie from this here. So we have to like call update. And this is what I mean, that we could do this with a bind instead, because this is exactly what bind is for. I just need to do like the mental gymnastics to be able to understand if that is feasible as well. I'm pretty sure it is, but let's do it like this for now. So this gives us the movie if we have it. If we don't get the movie, we have to return null, because then we have to wait for this to actually give us the movie. Okay, the movie. Once we have the movie, now we will say, actually this could be our new is initialized. Then we initialize with movie as an argument, because we need that. And then we basically say movie equals movie. And we don't even need initialized, because this will kind of count as the initializer in this case here. All right. Cool. And then reset will simply reset M movie for us. Hang on, but we might need it. So if until we have the movie, we're initialized. I guess potentially we could, I mean, let's say this is optional. We don't really, I guess we don't need to store movie. Yeah, we don't actually need to store it. But we do actually need is initialized, I think.
because yeah, I think we do need it. Because then up here is like, we don't want to call update if we already got the payload. That's the thing. So we actually have to look at, are we initialized or are we not initialized? Then we want to do this. So are we not initialized? We are going to try to fetch movie. And if we don't find it, we return null. If we find it, we initialize movie and then we start our animation. Do we have this in the open actually? No, I don't. But I might incorporate this into my project template, which is open on GitHub. Okay. Well, I'm not sure if I can manage to get it in there before tomorrow. Yeah, because it's like I don't want to have to copy it over and then do a bunch of updates and then copy over the updates. But yeah, this is probably gonna get lifted into the template project, so you could look at it. I mean, I guess I could copy over. All right. Yeah. Well, it will be available eventually. So we'll see. Maybe I'll do it tonight. I will clean up a little bit and then copy it over perhaps. Okay, so we get the thing out of the thing. If we get the thing, we initialize our state and we can actually do the thing. Actually, we do need movie. Oh, god damn it. Okay, we do need movie. And then we don't need this. And then we set you to movie. And then we go up here and we say const movie equals state movie, or else we do this. And we could also do like a break, like a state breaker here. Break with movie. So either we have the movie already, in which case we just continue play animation, or we don't have the movie, in which case we're trying to fetch it from the movie monad. If the movie monad is done and returns our payload, then we can initialize our state and this movie get populated with whatever the payload was, and then we can continue with our animation. Otherwise, we have to wait until, it's done. I'm almost considering to improve this language here a little bit. Like return null is like, it's so arcane that it's gonna mean like, yeah, we're still waiting. So maybe I'll change this to be like a union enum or something of like animation monad result or something, or event or something like that. And this is unused. You can be unused. Okay, there we go. All right, cool. So now the movie actually, it takes a monad instead, and it's trying to fetch that thing out. So we have to do the same thing for destroy now. So this, instead of just taking an entity, we have to say m entity, and this is an animation monad of that. Let's store that there.
animation monad of that. Hang on. Okay, actually now this is a bind. This is a bind. Or a lift, possibly. It's actually kind of like a lift. We want to lift a function to take an entity and then return a void, essentially. Yeah. This is a lift. So we need lift now. Another primitive, okay. A primitive, let's put it... It's gonna be one of these core primitives. Let's put it below bind, maybe even above bind, actually. I mean, it doesn't matter where I put it, but whatever. Let's do. It's such a core. It's just a core like primitive. So essentially, you get a function, and we get an animation monad that has the lift f. So the thing about lift is like in Haskell, you have like partial application because of currying. So lift is actually meant to be used on a monadic value. So what I'm gonna do is I'm gonna actually pass in the monadic value directly here. And since we cannot, well, we actually do know. We do know what type it is. Because it's gonna be the first parameter of f. So we'll apply this on the value. It's gonna be the first parameter f. So first param type of f. We don't have the first param function yet, but I'm gonna create it. And then the return type is, this is gonna be the return type of f. So basically, f is just a normal function. It takes some type of variable, returns some type of type, and then you get it. So now lift takes that function, and now it works within the monadic world. So it can work on like monadic values. So you give it a monadic value, it will return a monadic value. So in the monad. Now, and the question is, do I want to actually supply this now, or do we want to kind of do it later? Because otherwise lift would give you actually a function that takes m value instead. I think that's more what you're classically are supposed to use it for. Is like you get a function that takes a monadic value of type like whatever a, and it gives you a monadic value of type whatever the return type is. I think that's a more proper maybe use. Let's see if we can make that work actually. Okay, so I need first param. This is not the like the thing that could break this implementation, but I will do it anyway because I think we need to solve all like compiler errors before we can like, you know, even make this function here. But let's just do this one. So this takes a comp time function type and returns a type. And we're just gonna return type info f. It's a function. We have the params. It's gonna be the first param and just the type. And if it's an optional, I'm not sure what that means. I think it means it's like generic or something. So I'm just gonna say void. Okay. So now we have that. Oh yeah, because I want this to work with destroy. That's right. So basically what you would do is like you would do like m destroy is gonna be lift destroy. And actually it's gonna be like entity context destroy. Right? Because that has the signature we want. So they would take this function and turn it so that now it's a function. So mDestroy will become a function that takes a monadic value and waits for that to give us the payload, and then call the function on that payload and then return a monadic payload of void. That's what's going to happen. So that is what lift does. And then destroy here will simply be you know, it's just mDestroy essentially on m entity. Yeah. So that is a super core, very cool thing you can do with these things. All right. So how do we actually implement this now is the question. All right. Also, do I want a comma there? Does that work? Yes, it does. Okay. So we want a function that takes a monad type A, blah, blah, blah. So basically we can return a struct as the implementation function here. Let's make it public just in case, I guess. Actually, we don't need to make it public because it's like referred to from here. So that should already be a thing. Okay, the implementation wait. No, yeah, that's right. So we take a monadic value of A, which is gonna be this part here. Let's take A is first param, B is that. So we take a monad of A and we return a monad of B. Now it can't be void, it doesn't matter. So how does this function look? Actually, it's a closure. It actually is a closure. Yes, it is a closure. Which means if we call it, it needs F. But I mean, aren't all functions essentially comp time known? Isn't that the case? No, they're not. Not if it's, well, it's not comp time known if it's like if it's like a field on a struct. But will this ever be a field on a struct? I feel like if we have to make this comp time, I feel like it has to be a comp time known function, because then we can just use it here. We don't have to make a closure. Okay? Because making a closure is just going to be so annoying. Yeah. Because then instead of like when we do the lift down here, instead of just calling it, we have to do like, I don't know, dot call. I guess that's fine though. Or dot f. I mean, is that so bad? I don't know. But this is, I mean, it's already like, it's just comp time. So it doesn't actually matter. Now we can just call m. We can just call that on the thing. By the way, how come you're so into functional programming? It's rare and I appreciate it. I don't know. I think I got into it when I discovered Haskell for the first time a long time ago. I just loved how elegant it looked from the examples that I saw. And then I just learned more about it over time. And, you know, learning about the monads and arrows and a bunch of different things, which is just, it's just so, I don't know, it's just so intriguing to me. Like, it's more like also I'm very interested in different programming concepts in general. So it's like, and the functional programming concepts are very like, I don't know, they're more like mathematical, more like elegant in a way. Whereas like imperative concepts are more kind of, it feels like they are more like, I don't know, engineering. I don't know, man. I mean, both are cool. Like, I guess more algorithmically. But even though, like, you know, math stuff can also be algorithm, of course. But yeah. Okay. So how do we actually implement this now? We can bind MA. Oh yeah, we need a type. So bind, we're binding A to the return type of B. So we're binding A. The monad is, wait, what? It's MA, right? And then we need a function here, which can be a closure. It doesn't have to be a closure then, actually. So so now we can just we can't just bring f in here, because that doesn't return a monad. It returns a normal value. So what I'm going to do is I'm going to create another function here, which is going to be f and b, which takes like f a to mb famb. This is the famb here. Actually, let's just famb it. So famb takes an a and returns the monad b, right? That is what this function will do. Okay, and we get b from a f of a. So there we go. Now we have b. This is b. Okay. Why do you say unknown type? It should be b. I mean, I guess it's unknown because we don't know what the return type of f is. We don't know what f is. So anyway, and then we simply return pure b. So we're just returning that. We're basically kind of defining lift in terms of bind and pure. So we're binding m of a to famb, which means when this monadic value will like give us a value, we get it. Now we get b out from f of a, and then we just return pure b, which is just, yeah, it just gives us b in monadic form. So there we go. Now we have a function that takes a and returns the monad b, and we can use it in our bind. And this will be the actual monad that we will get. Now this is like the lifted function that works with a monadic value a and gives us a monadic value b. Cool. Hopefully this works. It will be really cool, because now it's like we just lift destroy into the monad, and now we can just use it to work with monad values. Which means that when we go to range attack, now, you know, destroy can work with a monadic value and move works with a monadic value. But I actually just realized something as well. When we do let equals, so there's an issue here actually. And the issue is replay stuff. I don't think it will be a problem actually, because identifier simply grabs into the scope to get the thing. It's not a thing that actually creates the sprite. The sprite is created here when we do the let, and then identifier simply goes into the scope. I don't think it will be an issue. The issue that I was thinking about is if I were to put sprite directly in here, that would be an issue, because both of these would like look at the sprite as a monad, and they would both create the entity. So that will be an issue if I were to put sprite directly in here. You have to be a little bit careful with the monad you're designing, if you design your own monad, to work properly. Because, yeah, you have to kind of follow some rules to make it actually work as it should. But I don't think this will be an issue. We are creating the sprite here, and it's going to be put into the thing. And then let is basically done. And then this one is doing the same thing. It's going to create the sprite. We're going to be putting it into project B, and then we're done. Okay. And then we're just using identifier A to get that out, and identifier B get that out. Yeah. And sprite just uses onStart. OnStart is very similar, I think, to lift actually. Although it's like sometimes it's like it takes void and returns another thing. It's kind of like that. Although actually we want game as well, so it kind of takes game. Although we can have a closure on. Okay, anyway. Let's see if this works. So now we have redefined our animation to this new way of doing things. Animation sequence 38, error union is ignored. All right. Let's catch unreachable. All right. 263, reset, expected 2 arguments, state and value, Q, melee attack. Oh yeah, right, okay, we need another one. No, we don't, actually, we don't need another one, because we already have pure. That's right, we have pure. So if we go to melee attack, we'll just go to 79. Now here is like, well, now we need a monadic value, and we have the thing that's supposed to be inside the monadic value, but we need a monadic value. So what do? We just say pure, and now it's a monadic value. There you go. Pure is your friend. It's kind of like lift, but for values, you could say. Okay, is there anything else? Also in here, 36. Move. Pure movie. Ranged attack 39. Oh yeah, move and destroy is not a thing, it's a function we have here, so we don't put dot there. Okay, now we have something over here, 42, get identifier is a key. Right, we have to return it, of course, thank you. Imagine without compiler errors. It would just like, oh, so you didn't want to return something. Okay, then it's just going to be undefined. I mean, that's basically how JavaScript works. Unable to resolve comp time value. Comp time value? Excuse me? What the hell is happening here? Comp time. What? Initializer of comp time only struct. Bind state must be comp time known. Comp time only is comp time only because of this field. Type of bind org. Really? Okay. I guess we'll move it out. We'll make it a function instead. Maybe that will work. I was thinking there's not much of a difference, like, but okay. Let's try this instead. I was wondering how long it takes you to basically recreate a JS treat. Yeah. And this is bind arg, and this is also bind arg. And the thing is, we also need this. So we need like, I guess we need like the payload as well. And this would be animation mode at P. All right. So now bind state will be stuff. Actually, let's just call this state. It's going to be bind state of P, which is actually T, and then bind arg is type of bind arg, and then you are going to be state. I'm not sure. I don't know if this is gonna work. This feels weird. Like, why do I encounter this issue now? I don't know. It still has to be comp time known. A comp time only struct components because of the bind arg field. For some reason. Is it because it can be different? Like, it doesn't make sense. It's just a normal, like, yeah, this field depends on the bind arg that we use. So and then I was like, and then these functions should be like produced for each different type of closure that we put in, which would be the bind arg can be either a closure or function, right? That's how I see it, but no. Apparently this needs to be comp time known. What the hell? Because these are types. They are comp time. They have to be comp time known. Man, what was the difference? Is it because we're calling it with a comp time known thing? Oh, wait. We're calling it here with a comp time f. Well, f is comp time. I guess this then maybe becomes comp time? No, that doesn't make sense. Just because this is comp time does not mean this is comp time. Because the f has a pointer which is then resolved in. It just means it's a const. It just means it's like it's a pointer that we can. We know what pointer fam should have essentially. And if we do this, then this is out of scope. Right. It's still complaining? Use const component for a function pointer type. Oh. Is it because of this? Actually, wait, let's go back. Hang on. So bindorg, if bindorg is a function, actually, let's do like bindorg massaged. If type info bindorg is a function, we have to make it into a pointer. So then it's a pointer to bindorg. Otherwise it's just bindorg. Hello Infinite Coder, what's up? Welcome. Are you streaming today? Or did you come from the stream? How's it going with the... What was it now? You will. Nice. And what was it? There's a game jam. Right, there's a game jam. Yeah. I was thinking of the... I forgot about the game jam actually. I was thinking of the thing you were working on when I joined yesterday. The compiler, right. The compiler, yeah. What kind of language was that, by the way? Has to be dot. Been like years since I started working on it. Goals shifted, designs changed, but I have faith in this rewrite. That was Rust. I'm compiling from Rust. I mean the actual, the language. Oh, what the hell? You need like a whole bunch of stuff. Can I just do this? Yes, I can. Okay, cool. What is this? Element? It's a type. Sentinel. Oh, that's void. And then null. Okay. Oops. Attributes. I guess it's a, is it const or what? Yeah, it's const, yes. True. It's Rust, but you're compiling for Rust or generating C. Oh, I see. So you're like compiling Rust, you're using Rust as a compiler. Although there is an IR, but there is no parser for its principles going on. Okay. Yeah, that's kind of like the game dev DSL that I'm making actually. I'm using Zig as I'm extending basically Zig as a compiler and using it to compile some code. But it's compiling into a Zig executable and running it at the same time. Well, actually, it's kind of like... Okay, I can show you here, actually. So this is the... it is just an example syntax here. I haven't actually... This is not... I'm just using Zig syntax here. This is the DSL here. So it just looks like Zig here, essentially, right now. But I would see whatever this would be here. Yes, game gdev, yes. And so if we go to main, so this part happens in comp time. So the compilation happens in comp time, and we get like an IR out, which we can then like evaluate in runtime. So when you compile it, it like takes the source code here, it compiles this source code into an IR, which is then just like, it's kind of like evaluated here. So you could kind of see it as like we're compiling to kind of like bytecode, maybe you could say, or you know, whatever parallel you want to use, and then we're evaluating that. Now CT is my compiling core thing library. I'm calling it comp time because it's compiling in comp time. Just I don't have a name yet, but yeah. So yeah, pretty cool. So I'm just trying out. I actually, I encountered some weird comp time bugs in Zig, where it's like you have a member function, which is just, you know, a struct with a function on it that takes self as its like argument, and then you can call like, you know, instance dot function to have it as the parameter of the first parameter into the function. And so a member function, and it like all of a sudden the member function, it said that it got a type as the first argument for some reason. Normally it would get like the instance of the struct, but all of a sudden it got a type, and the type was U0 that it got for some reason. So that was really strange, because that would normally be a compiler error that you would try to call the member function with a type as its first argument, but somehow that came from, you know, the inner workings of the compiler somehow. So yeah, that's interesting. So I had to add this guard. It's kind of funny actually. I had to add a guard. Where was that? Probably here. Yeah, I had to add this guard. So basically a self is a pointer to this, right? This is the member function. it is comp time, so, but that, I guess that doesn't matter that much. And then I just have to check, what is the type of self? Well, it's a type, okay. Okay, then don't do anything. Because I got weird compiler errors down here, which said that, hey, you're trying to access depth on a U0. So that doesn't work. So I'm kind of guarding against, okay, this is like a workaround here. It's the first time I had to do something like that in Zig, actually. And I'm guessing it's just because the comp time stuff, maybe, you know, it's not as robust as I thought it was. It is very, you know, it works very well, but this was a very strange issue there. Anyway, let's see. So you would be the massaged version of the bind, and here we're working on a monadic animation, or the animation monad for this game here. Bitcast type 0. Yeah, exactly. I don't know. Because I looked at the places where I actually called the function, and every time I did, it was just 2 places. And every time I called it, you know, it didn't make sense that it would be a type that I put in there. So, so that's what's happening there. Okay, where are we now? Wait, did it succeed? No, it didn't. We are, right, so we made this thing. And you're expecting pointer size found type. Wait. Oh, the element is bind arg. Yes. And this size is like 1. Right, there we go. What do you want? Expected void found entity context. Where are we now? We are identifier. Right, you need game and context. There we go. All right. Type, blah, 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 does not have, okay. Right, so now we have to support function pointers as well. So this would be, if this is a pointer, I guess let's do a switch on type info arg actually. If it's a function, we will return arg. Else return, well, if it's a, I guess if it's a struct, we will return this. If, and otherwise we get a compile error saying you are bad. No, but invalid input. All right. And if we get a pointer, it's not, we get a pointer p. You have a child that we want to return. Yes. I just need to kind of, I need to kind of deal with a thing here. 1 second. I'm playing like a, a board game, and people get mad when I don't do my turn when I'm streaming. All right. You do that, Infinite Coder. Good luck. Do you know what you're gonna make, by the way? What is the theme? Blank page. Cool. All right. Because Sigma abstract themes. Paper wheel pulls me. Nice. I actually have like a project that kind of fits. I don't remember where it is right now. It's probably like in an old place somewhere. But yeah. Yeah, good luck with that, man. Hope you have some good ideas there. Really want to turn it into a piece of paper. I guess that works. Like a paper plane. There's a nice paper plane minigame in WarioWare, one of the WarioWare games. Type has no members. Ah, we have the same issue here, right? If it's a function or if it's a pointer. I don't want to spend a bunch of time making this pretty here. Okay. Now, what did we do? I mean, I guess, I think what we want to do is we want to try out the ranged attack. Oh my god, it works, except it crashes. Okay. But I saw something it created, so it does work. But what is the panic? What are you panicking about? Panicking. Game 264, get something. Animation sequence 479. As moving. Okay. Oh yeah, because when we reset, we also need to set you to null, because otherwise we will try to use the same thing. Makes sense? Alright, let's get up to one of these ranged. It works! Oh my god, that is so good. Okay, so let me show you what we did. Why it's so cool. So basically, I mean, this animation monad, this is the animation that you saw now. It's like we have things happening in parallel, which is it's kind of like a scheduling system. So these happens in parallel. We create two sprites, right? And then we also bind them to identifiers. So prototype A, prototype B. And then we call another like animation here, which moves them to a target position with the speed, and we destroy it. And we pass in like identifier to be able to put them. So it's kind of like, you know, programming in a sense. It's like a new programming language sort of in here. And so move and destroy will just sequentially first move, and because it's a sequence, it needs to move play this move animation first, and then it goes over to destroy it. So yeah, pretty cool actually. If you see it, how it worked from like before, which is all this shit over here. So it's a lot less stuff we have to do. We can actually delete all of this. 86 lines went down to... What? Hang on. Oh, I'm looking at the wrong thing. This is... No, it's 40 lines. Went down to 28. We saved 12 lines, but also like a lot of readability here. So I would say this is a major win here. Now, one more thing that I would like to add, which would be cool and kind of maybe even pretty simple actually, is like a scope stack. So if you have a scope here, you would these projectiles will be defined in this scope, so they won't be available from outside the scope. So we're creating a local scope so we don't pollute the global scope essentially. So once the scope is like done, these get destroyed essentially, or the whole scope gets like destroyed. So how to do that? Well, let's go over to our animation sequence. I'm just gonna, continue here. This is so fun. So instead of just having one scope, we're now gonna have like a scope stack. So let's have a scope stack. And this scope stack is a little bit different. So let's make scope stack. All right, and here is one scope. So we have one scope, and then we have a scope stack. We can also... Do we want to... I mean, I think when we deinitialized, I don't think deinitializing a scope is super important. Because the scopes are like... They're probably not going to be that much happening in here. So, and everything is like from an arena standpoint as well. So even if we deinitialize something here, it won't actually do much, really. So, yeah. We simply just discard this scope, and there we go. But the scope stack, so the scope stack, how it works is essentially, it's a stack data structure, which means you start with this, it's basically a list. You start with 0, you push a scope onto the stack, and then you pop a scope. So we have a bunch of scopes, which I mean, we could make a generic stack thing, but I'm just gonna make it's just gonna be an array list of scopes. Okay, and then let's make an init function. This doesn't take anything actually, and then the scopes is init arena allocator. It's so good that we could use the global allocator, by the way. That's so good. All right, so we got that. Now we need push scope. We need self. This is just gonna append the scope. Okay, and then we pop a scope. This is gonna, is there a pop? There is a pop, and if it fails, I don't care. Actually, we don't really care about this scope. So we pop the scope. We don't have to supply a scope to pop. There we go. I think that's basically, this is the basic things that we want. Now, another thing that we would like to do, like it depends on how our visibility will work. like, let's say you want to access projectile A, like the identifier, and you're deep in nested in some scope somewhere, you probably want to be able to access from outside the scope as well. I think it's not super necessary right now to build that. So for example, so basically what we want here is we want to be able to get some identifier, you know, here. And this gives us a optional value, which the value is this here. Okay, so then this would be scopes. And then we get like the last. We get the last thing, and we get, I guess potentially there could be no scopes. No scope. Let's add a, you know what? I'm thinking maybe we should start with a global scope. Also scope stack. Let's just do deinitialize, I guess, or reset. Now, the question is like how. Yeah, let's actually just handle it in here. So when we initialize, we will add a root scope. So we would get, let's just do like scopes is array list of, array list of scope, and we'll initialize with arena allocator. And I will append or we can do this equals this. Scope stack, scopes, append. Wait, it's empty. Okay, right, it's unmanaged. That's right. Yeah. So arena allocator, and then the item is gonna be. Well, hang on. It's just gonna be like push. We're just gonna push, and the scope is just in it. There we go. So we are starting out with a scope as a pushed scope. Okay, and then. Reset will say scopes, I guess, like clear retaining capacity. We just discard all the scopes essentially. All right, so to get a thing, we get the last scope. We should always have a scope. But I guess if we don't have a scope, then return null. Otherwise, we would just return scope and then get identifier. Okay, so that's this kind of defines how the visibility will work. And right now, we're just looking at the last scope. So inner scopes won't actually have access to outer scopes, which is fine right now. Okay, but it will make things maybe a little bit less composable, perhaps, but whatever. All right. So that is the scope stack. And now, I guess what we could do, we could also lift these functions out because so that this is kind of the API here. And this would be like the scope stack. Actually, also, yeah, we need like, you know what we need actually? We need like get active, get current scope, or get deepest scope, or something like that. Get last scope or something. I don't know. Get last scope. This gives us a scope. We're gonna return scopes get no. This is the I don't know why do they have get last? They have get last or get last null, but they have no version that gives you a pointer to the scope. I don't like that. There should be a version that gives you the pointer, because you have to do this and then that to get it. I mean, you can get it, but why have those two versions and then not one that gives you the pointer? In your custom debug, do you track and log how many resources are reserved used at runtime? You actually for reading the scope? No, I don't. But I've been thinking about it in my mind during this session as well, like a little bit over time. So I don't think it's going to be a lot of issues, especially all the animations are like cleaned up between every time they're played. So like I don't think it's gonna I don't think there's any like memory leaks or anything like that that's running away, but they could be. But I've been thinking about it a little bit, and my spider senses are not detecting anything right now. All right, so we have get last scope. So this would be used here, for example. Yeah. So let would get the scope is going to be self scope stack get last scope, and then we're gonna use let here. There we go. And then we're basically doing the same thing here. We're getting the scope. We are calling get, and here we call remove. All right. Okay, and now context of scope. Instead of saying context of scope, we just say context. Okay. And, well, let's just see if this works for now. Hello, Mativa. What's up? What's up? Welcome, welcome. All right, we got some compiler issues. Scopes append. Oh, you need an allocator. That's right. There you go. Arrange it. Oh yeah. So now, okay. So we're up to this point. Is this Rust? No, this is Zig. Z-I-G. Were you expecting Rust? All right. So we need. So what I want to do now is I want a scope. Let's just copy this one, and we'll do like scope state, scope. Actually, let's just call this the closure maybe. or the state. I forgot what I called it. Whatever. You don't need anything actually. Maybe potentially a label for debugging purposes. So actually we don't need a closure for this one. I wonder if void works here. Okay, so scope. What do you actually want to do? Get state. No, we don't need state. We don't have a state. We actually don't do anything. Yes, we do. We want to push a new scope. That's what we want to do. And the scope is just in it. There we go. That is the scope. You push the scope. Reset will just pop the scope. So it actually just pops the scope. But this should happen like in the same order. Actually, you know what? It doesn't happen in the same order because the sequence resets things. Hello, Turbofish PK. What's up? What's up? Welcome, welcome. All right. This is actually quite the conundrum. Hello, VVAX. Welcome back. Yo, yo, yo. Hello, hello. Turbofish. Can you shortly describe Zig? It's a low-level memory management language. It has very good interfacing with C and a lot of things in common with C. It doesn't have classes. It doesn't have interfaces or any fancy stuff like that. It has structs, functions, and a major thing that it has is like comtime, which where you can basically like create types and do other things in comtime depending on. It's like you can code. You can produce types through code, you could say. And other than like functions and other functionality as well. And you can basically generate code through code, you could say. It's kind of like C macros, but it's a lot more like, you know, robust, I guess you could say maybe. Compile, yeah, so it's like const expressions, if you're familiar with, you know, C++ const expressions, but it can produce types and not just, you know, a bunch of values in a very strict rule set. So you don't need to do anything. This problem here, pop, it doesn't work if this isn't called in the correct order, which is it's not doing that right now. I was thinking like maybe we should, instead of doing that, we should have like an ID maybe. Or we could just go to, we could go to sequence and we could reverse the animations before we reset them. Also, we don't want to then we don't actually want to reset things that haven't been played. Actually, it becomes more important now because it's order dependent. So basically, let's do, what we could do is like reverse. Animation monad T, items is state animations. Okay, we reverse them and then we reverse them back when we're done. But we don't want to go through all of them. Oh man, and we just want to reverse the ones that we actually care about. So animations that's been running. So also another thing, I don't think we should allow resetting a thing that is like mid. Yes, we do, because that's basically what we're doing here, essentially. No, actually, we don't, because index is always going to be, like if reset is called, we can assume that we have already played all animations, actually, yeah. Okay. We just need to reverse the order and then reverse it back. For parallel though, man, okay, this is the issue, man. Okay, with parallel, how the hell does that work? If you create, you have a scope. You create two scopes in parallel, then each parallel kind of node, I guess, would have its own scope. I guess the parallel will have to push a scope to each of its children, actually. Assumptions are dangerous, yeah. I know, man. The things that are running parallel, they need, like, each need their own scope, I guess. But then that will mess with how this works. For range attack, will this work then anymore? It will, well, no, actually we won't, because this is parallel, so all of these are gonna have their own scope. Maybe we should only worry about that if we create a new scope in a parallel. Actually, maybe it doesn't matter. 1 second here, I'm getting a call. Alright, I need to go here soon. But yeah, we had a good run here. But this is actually a little bit of a conundrum here. Is it a conundrum though? Let's say we have a scope. Well, for this part, I guess it doesn't matter too much. It's just if the problem is here. If we create two scopes here, and this is just, I don't know, pure void, it doesn't do anything. It just pushes the scope and then nothing happens essentially. But the issue is this will push a scope. Like, is the order of these pushes are not guaranteed. Because what if you have one that is like, I don't know, if you have like something that after 3 seconds, then you push a scope. This pushes a scope here. When we reset these, presumably this would reset this one, or reset this one first if we're going to reverse it. And then we're resetting this one, which now is out of order. Actually, you know what? It doesn't, I think it doesn't matter, because when we reset par, it has already been completed, actually. So everything that was inside is done, so resetting par wouldn't actually matter. Wait, resetting a scope, do we actually want to pop? No, this doesn't make sense. I actually... no, because everything that's inside has to be in the scope. Okay. No. Okay, I was doing this wrong, actually. Scope takes one argument. It takes the monad. It takes a monad as an argument. Okay? That is what's happening. And what it's going to do is it's going to run this monad until it's done. Before it starts the monad, it's going to push a scope. And then it runs the monad. And when the monad is done, it's going to pop a scope. That's what's going to happen. Okay? So, but the thing is, if it happens in parallel, if let's say we have two scopes running in parallel, let's say we copy this essentially, we run in parallel. Let's say we have like a repeat. This is like repeat sequentially. Let's say we have a repeat, repeat in parallel, like this. 2. So we repeat this in parallel, which means we kind of create two instances of this that's running in parallel. Now, the order is not like guaranteed that the first scope will push, that scope will have their, like, these things actually like populated in its scope. That's going to be like the deep. Also, it's going to be like the deepest scope. It doesn't actually make sense if yeah, it doesn't make sense that they would have a tree like... No, it doesn't make sense that they would have like a scope stack then. It makes more sense if the scope structure maybe is a tree. So each thing in the... Like sequence is no problem. Sequence is like... We can have an order determinate... It's determined which order things are happening in. So sequence are not a problem. It's the parallel that's the problem. The parallel is the problem. So what if each node in the parallel basically has its own kind of root scope, maybe? But again, that would be an issue here, because then we can't let these things anymore. What we would have to do then is basically sequence these two and then have a parallel running these two, and then these identifiers would have to be able to see the outside scope. That's what would have to happen then. Also, each monad would have to have like a scope assigned to it, essentially. Maybe it has like a pointer to the scope on itself, or something like that. Or when update is called, when we call update, we include the scope. Maybe that's how we want to do it. What you could do is stacking each parallel item by the sequential order and then run. So the first of each gets done first and so on. Well, that's not really how I want it to work though. Like they should be running in parallel. Everything here in here is going to be run in parallel. It's just there has to be a way to kind of bookkeep this in a better way. So what I'm thinking is like the scope can be passed into the update function. So if you pass the scope into the update function, then this scope would pass the scope new. This will make a new scope. That we don't actually need a scope stack. Actually, we don't need a scope stack. We just need this scope monad to kind of have the scope on it, I think, and then each child will just get that scope. It will call update with a new scope that, or with its scope that then the rest will kind of share here. Yeah, and it could also be a scope stack as well. That is like, I guess it could be like inherited from the parent, and then you get like a new scope stack from, and then the scope stack would essentially just be a slice of it would just be a slice of like the previous scope, so we can save that there. Right, and then what happens then? Then it should be that par should call everything with the scope that it has. If a new scope gets added down here, since we don't like pop scopes anymore, the order doesn't matter anymore. It's just that this scope gets, like, its children will be called with its new scope, and whenever this monad is done, it's gonna clean up that scope or just discard it, and then the same thing here. So I think that actually solves that issue. So yeah, so the update function actually needs a scope as well in this sense. So we need a scope. And we can change how the scope works here. We can, instead of having, actually we need like a scope stack. And the thing is, probably this won't be dynamic list then. It will just be this. Yeah. And actually, yeah, let's this starts out as empty, I guess. Or we initialize it with something. All right. We can also have an empty. Okay. Reset is probably not needed, so I'm gonna remove that. We don't actually push or pop into here. We could, I guess we could get the last scope, but there's no reason to get the last scope. We have to implement a way to kind of see, like, to get variables in here. We don't get the last scope. What we do is we go through each scope from the end. So it's like scope's length, and the actual scope that we're looking at is gonna be scope's length minus I minus 1, and then if, and then like return scope get identifier or else continue. Okay. And then if we're down here, we're gonna return null. Then we didn't find it. So there we go. So now we're looking for all the scopes from the newest one first. We're looking for the identifier. So basically shadowing is a thing. You can shadow different things. And we try to find the identifier. If we don't find it in the first scope, we look for the second scope and so on until we find it. So now we can actually get like things from outside. We also need like things like yeah, we also need like remove. That is going to be, do we actually need remove is the question. I think we do. Because you could potentially, let's say you repeat. Yeah, we need remove, yeah. But remove should probably only be on the latest stack, maybe. Yeah, it's gonna be on the, or it's gonna be like on the current stack. You know what? We should just have the scope. It's just, yeah, it's just gonna be on the last scope. So actually we do need get last scope. So this would be like self get last scope, remove identifier. Okay. Now there's no prioritization. There's no prioritization. It's also actually in the sequence we don't actually need to worry about order anymore here. We don't need to reverse or do anything here. 1 second. All right, I just want to finish this thought here. It just feels like I'm on a roll. I need to actually roll this out. Write this out. All right, so let would only create on the last scope. So let would get the last scope. And then we use, and then we just let there. Cool. All right. Nice. And then it's like we don't actually have a scope stack here. I don't think. We need to keep like a, well, or do we have a scope stack here? Maybe we do actually. We can set it to empty. The arena's gonna reset anyway, so okay. Maybe we'll reset the arena first. Before we use it again. Update. So, update would now actually take a scope stack as well. And possibly, yeah, and reset as well. So actually, yeah, this is the, but self scope stack, that is like the root scope stack. So yeah, yeah. So I guess that's what we start with. All right, so now every function needs a scope stack. And then this is simply gonna put this in the update function here. We're simply gonna forward this, the scope here. And that will guarantee that everyone will have the same scope. Hopefully. And here we also get the scope stack, but I don't think we need to... Well, actually, we do need to worry about it, because when we reset, we do want to put the scope there. All right, now we have to basically do this for all these functions. So let's just go from top to bottom here. So we have pure. You don't care about the scope stacks, but we need to add this anyway. Do will do things. Yeah, you don't have, like, you don't do anything with the monad or anything, so it's just it's like a side effect thing. You are already monadic. I am logged in. Hello, code guy. Yeah, I'm starting to get very low amounts of time here, so that's why as well. Bind. You have a scope stack, and you have to put the scope stack in here. And you also have to put it here. Yep, that's it, I think. Actually, oh yeah, I think I said that we, like, if mu was created, it should have been completed, but then it kinda is discarded. So we don't I don't think we actually need to care about that. But this one we do wanna reset here. Sorry about my bot. And now, okay, so scope is different now. So scope will take a monad, and it will basically, it's going to have the same return type as the monad. And then the implementation is like, we don't push or pop. What we do is we receive a scope stack, and we'll create a new scope stack. So new scope stack is going to be a scope stack initialized with new scopes. New scopes is going to be basically, what's it called? Concat, or sure. Let's concat, and we're gonna concat scope. Actually, this is an issue because they're not mutable. We're gonna get like a snapshot now, or they are not pointers, so we get like a snapshot of the scopes. We have to kind of store them in random places, unless we make like a rope-like thing. We can have one that is the current. I guess what we could have is like one that is the current scope, and one that is the previous scopes. But then we're gonna reach the same issue again. We just pushed it like one thing further. Yeah. So I think this has to be pointers actually. Yeah. And then actually this whole thing is a const slice, so the slice itself won't change, I guess, but it has pointers to mutable scopes. Okay. Yeah. So we will do pointers to scopes, and the slices are going to be the current scope plus a new scope, which we have to actually kind of make here. So we have to make a scope pointer is arena allocator create. We have to create a scope here. All right, sorry, I got invaded here. Okay, let's just see if we can finish this here. So, right. So we create a new scope, catch unreachable. We populate it with init. We will put the pointer here to concat the things, and that's going to be the new scopes. Okay, so that's the new scopes. The thing is also now actually scope kind of needs a closure. We need to we need a closure where we need to keep the monad. That is type of monad. And then we need the scope as well. So this would be the scope stack here. All right, and then you are closure, and monad is monad, scope stack. Actually, this is optional. So let's make it optional, because basically here we want to check like, okay, do we have actually state is get state closure. If state scope, then we already have the scope. So then we can just say return state monad update state monad context scope. All right. I guess it has to be mutable. There we go. So we run this monad. If we already have the scope, we just run the monad with this current scope. This is our like scope instance. If we don't have the scope, we have to initialize the scope. So here we're initializing the new scope stack, and we put the scope stack onto the scope, which should be the new scope stack. Or we just say state.scope equals that. And then we will run this as well. Except this one is like scope, and we can like unwrap it there. All right. There we go. So if we have a scope, we call the inner monad with this scope. If we don't have a scope, we will create it and we will start using it here. And then I guess what we could do otherwise is we could just say if we don't have a scope, if this is null, we will create it. We can also do like this equals, if we have a scope, then we get the scope out here. Otherwise, we have a thing where we create all this crap with this whole thing here. And we will break new scope stack that we create here, and then state.scope equals new scope stack. And actually, you know what? We actually need to do this. And well, let's just do this actually. All right. So now we have that. Now we can just run it like this. Wait. Or we can just say we can just say if this is null. So many iterations. If this is null, we just populate it and then we use it. Okay, there we go. I'm still trying to find like good patterns for those kind of things. The optionals are tricky sometimes. All right, so if we don't have a scope, we create it and then we run the monad. Otherwise, we just run the monad. All right, so reset. I mean, I guess essentially it's just gonna be like we get the state. And we're just gonna say that the scope is null. That's basically all we have to do, I think. Because the scope doesn't really, it doesn't make sense. It doesn't have like reset or anything. So, yeah, we just remove it. And we also have to, and this is the previous scope, I guess. Now what's interesting here is we could potentially like use the scope here directly to repopulate it, I guess. Whatever. And the monad we also have to reset as well. No, this doesn't make sense. We need a new scope to be able to reset the monad with the scope we had. All right, we reset the inner monad with our scope. Right, and then we do that. Okay, so we don't need that. Cool. I think that should work. Okay, now we need to do the same thing here. So scope stack. You need scope. And the thing is here now, we don't call context let. Actually, we should remove these functions because they don't make sense now, because we should use the scope let instead and not the context. So there we go. We're using the scope instead. Cool. And then same thing here. We are gonna use the scope to remove, and reset also needs scope as well. All right. I guess we'll do it in reverse order, I guess, maybe. I don't know. It doesn't make sense that the inner value would have the identifier though. Okay. And then identifier is same thing here. This just returns the scope identifier. Reset, I guess, yeah, it doesn't do anything. Sequential. You simply pass in the scope. That's it. Same thing here. All right. Repeat. Yeah, same thing here. Reset. All right. Parallel. Already did parallel, I think. Simply calling, pushing in there. Reset, we just pass it into reset. Yeah. Cool. Move can be refactored into bind, but I'll do that later. All right, so this one, we actually want to update this guy. Put the scope in there. Nothing else is like monadic in here. Do want to reset with scope. All right. Q. Move state. I don't care. Call closure. Yep. That should be very generic. On start is another one. I guess we don't care about the scope because it's not monadic. It's just a function that basically is called, and then we use the payload to return. It doesn't do anything monadic here, so we don't need to worry about the scope stack. All right. Sprite doesn't care about the scope stack. Destroy doesn't care. Okay, there we go. Now, the context not used, good. Okay, so if we go back here now, this should be like runnable at least, I think. Except we don't have repeat parallel. But okay, I'm gonna go through this mental gymnastics again. So repeat parallel, we create 2 instances of this, which actually means we create 2 scopes, different scopes that does the same thing. So that should be correct. And then these happen in parallel, but since these are like different identifiers, it's like the order is like not guaranteed, although it's probably gonna happen in sequential order. It's kind of like firing off a bunch of async actions, essentially. So this will happen first, then this happens, but they might be, you know, they might take some time before they're done. For this one, for example. Also, this is another thing we don't have, but yeah, I think this is good. But I'll just remove the things we don't have and see if that works. Now I guess there's one more thing. It's the root scope. The root scope is created empty. So I guess like if we don't have a scope to put stuff into, it will crash, I guess. Let's try it and see what happens. It is some kind of declarative function lib for zig. I mean, it's very specific to my game here, which is like it's like an animation system. So it's like but yeah, essentially it's like a monadic declarative way to kind of define these animations. So it's just because I like this sort of stuff. So okay, what's your issue here? Repeat scope. Scope is a thing. Wait, type enum, there's another function. Repeat. Oh, I see. Right, we have the same issue that we have with bind. God damn it. What if we just say that's okay? Let's just say that scope. So this monad, let's just say it's like it's just T, right? Okay, I think that should work. And then sequence 3. But you do FP for your day job? No, I don't. I just really like it. Does Zig have proper monads? I don't know, actually. I mean, it doesn't have. You can't like. Well, it doesn't have type classes, so you can't just like add implementations. But you can probably just make one large function that considers every type and calls the appropriate like implementation functions. I mean, what you could do is you could follow a pattern. You can follow an implement phase, like an implement pattern, and then the function that calls like map, or the map will, for example, look at the type you put in, which has to be then. I guess it's either gonna be one of the built-in types or the struct, a struct, and it can look at if the struct type has a map implementation, it can call it. So you could do that actually instead, yeah, because that's how it uses. Like for example, a struct can have a format. Let's say you have a type here. This is a type, so you can have a format function. Now this format function is like, it's kind of like used for the. We can put. Oh. All right. Yeah, I basically have to go now, but basically, map would be standalone. Well, it kind of, yeah, it would be like part of like, you could have it like part of a library, like a monad library or a functor library or whatever. And, you know, it would be very generic. You would have like map is a function and takes like, you know, any type essentially, and then returns, you could have a function that tries to calculate, it takes a function as well. And you can have a function, you can have something that tries to calculate the type. So like map result or something based on like the type of X and type of F. So it could try to like introspect or whatever it's called onto these types to kind of figure out what type it should be. Like you could have like, let's say, let's just play with this idea here, because there are like, let's say you have an array content t type, right? And then this gives you a type, it gives you a struct. Let's say on this struct, we have a function that is like map this to content u, and this will give us a type, and the type is just array of u, right? So then map results would be a function that takes the monad or the kind of container type, and then it takes the function and gives us another type. I'm just I'm not sure if this is gonna work, but potentially it could work. So then it's like you could check if has declaration m map result. Oops. And you can do better. You can do more like better like constraint checks here. You can check that map result is a function that returns a type and stuff like that. But we're just checking if it has a declaration called map result. Actually, it should be a field. I think has field. Do you work for is it a field, or I think it's a field. But anyway, no. Yeah. And then you can just call map results and return it with the return type, you know, of f. You can get that as well. So then essentially f would be a function with a return type. You get the return type out. Now you have a new map result. This is now generic across all types, essentially, well, across all structs and things that can have functions on it. So it will find that, oh, you have a map result function. Let's just use that function. Okay. There's could be other ways to do it as well. Like you can have the ifs right in here, like if m is equal to an array of, but then you need like t. But I guess t would be like first param of f, you know? So if that is true, then we just return array of return type of f. But that's, you know, that's less, you know, then you have to put all these checks in here. This makes it so that you look at any type that implements this function, and it would be like a pattern that you would have to follow there. So then let's say you put an array here, then this result will be an array of whatever return type this is. So that mapping does work. And then, you know, I guess you would just, I guess also here is like you can have like if comp time has declaration type of x map. So that could also be a check that we do, and it can be more. You can check it in other ways here, but let's just say that this has a map function, if it does have a map function, we will return x.map f, for example, and then otherwise this will be like a compiler error down here. So map not implemented, for example, and that will all be caught in compile time. Oops. Okay, and then you would have like the map implementation function here is like map implementation function takes self and returns and then a function that takes, you know, t and returns something else. Actually, this has to be an any type, and then we get an array of return type of f or type of f, whatever, you know, and then, you know, whatever this would be. But yeah, one thing here though is that since Zig is manually memory managed, you can't just create a new array and map the values, you know. You have to actually allocate those things. So, but I did find a way to do it, sort of. You could use a global allocator. So you can kind of like make like garbage collection sort of happen. I'm kind of doing that right now. But yeah, this would be the way to kind of do it, I guess. So this would be like kind of the implementation of different, you know, different patterns and monads and whatever. But for example, there's no way to create it. Like, let's say you create all the primitive types you would have to actually implement in here. The primitive types doesn't work like this. You would have to do extra checks for primitive types, but those are limited, so you could just go through each one and do the thing. Well, primitives primitives doesn't even make sense in the sense of map. But I mean, in the case of like type classes, like more generally, right? So the allocator would have to tag along. There's no implicit context like JODing. Yes, but you can, as I said, you can have a global allocator which you can then like access through from anywhere. 1 second. Okay, but anyway, yeah, it's a cool little thing there. It's a good exercise here to do these things. Okay, let's see what where are we? Let's see if I can fix. Let's see if we could just get this running here. So expected t from const t. Really? Oh, okay. Well, let's just do that. Whatever. Whatever. Expected t from huh? Oh, they are. Okay, what if we do this? Okay. I was thinking like, yeah, that should work. Can I ask what's this build runner plugin for Navim? It's called Overseer. It's a really cool. It can run any like. I have this this little, basically this here. I map F5 to command overseer run command, and then you just put the command you want to run, and then it does a lot of stuff. It keeps track of the thing. Everything. Yeah, this is insanely nice, actually. You mean this in Emacs? I thought you had everything in Emacs. All right. I've never used Emacs. I'm probably never gonna use it. No, I'm not gonna turn this into a fight here. No, but yeah. Where are we now? Let's focus 301 error cannot blah blah blah. Assign cut to a constant. Oh wait, what the hell? There we go. Ah, it compiles. And you know, it works. Nice. I mean, we don't know if it works because we aren't really testing the kind of limitations that I was thinking about, but yeah. Cool. All right. Yeah. So you see what's happening here. I actually implemented like a stateful monad. You can create a new scope with where you put things in. You can bind things to names. So this sprite is like creating a new sprite. It will be bound to projectile A. This will create another sprite. It's the same thing. And this would be projectile B. And then we move those in parallel. Everything here happens in parallel. So they will move and destroy those to a target position and destroy. Awesome. I'm using let. Yeah. It's because it's a monad. I could have used bind. I like the word bind, but bind means something else. So I also have bind, but it's kind of messy to use. But it does work. I'm using it like internally for some things, but yeah. Like bind as in you know, Haskell bind like this. But yeah, anyway, that's gonna be it for this time. Thank you very much for watching. I need to run here now, but yeah, awesome session here. Cool. Let's see if we can send you off. Oh, thank you, Joseph, for following. Let's see if we can find. Is anyone zigging it? No. Infinite Coder. Yes, there we go. Infinite Coder. Hey, let's go. All right. Thanks for the stream.